Okay, so let's start the final event of the RetroFeed project. So thanks a lot to all for joining us to this final event here in Brussels, the people that are here in the room. So thanks for coming. Also for the people that are online. So yeah, some briefly remarks of the meeting. So the meeting is going to be recorded. So and then will be uploaded in our webpage, just to know that well, the idea is that we can share all the conclusions and all the feelings that we will have from this meeting with all the audience, in order that they have the much information as possible about the project. Also for the people that are online, you have a chat where you can write your questions, and then during the roundtables we will ask to the panelists to ask these questions. Okay, so let's start very briefly with the agenda of the meeting. So we are going to start with a speech from the project officer of the RetroFeed project, from Lucia Fernandez from ADEA. Then we will have a presentation of the RetroFeed in a very briefly way, in order to you have an overview of the project. And after that, we will have the roundtables with the demo sites, with some of the partners around the day, in order that we have the opportunity to discuss some of the results, of the impacts, of the challenges of the project that we have faced during the last 4 years. So now I think that we can start with the presentation of the project officer of the project. So Lucia, for the presenters, please, you have to be there in order to pass the slides, okay, in this. So Lucia, the floor is yours.
Thank you. I guess there is a microphone. I don't have to worry about it. Okay. So yeah, thank you. Good morning, everybody, and thank you for inviting me for the final event of the RetroFeed project. It's a pleasure for me to be here today. And I will give a short presentation on climate neutrality and circularity in process industries in Horizon Europe and also in Horizon 2020. At the end of 2019, in response to the climate challenges, we launched the European Green Deal, which is a package of policy initiatives that aims to set Europe in the transition, in the path for the green transition. Also to support such transition in the last 4 years, a series of strategies, plans and regulations have been prepared or revised. For example, the Circular Economy Action Plan, or the Critical Raw Materials Act in relation to the use of resources in Europe, the European Chemical Strategy and the Zero Pollution Action Plan for a sustainable and non-toxic environment, or in relation to the energy challenges, last year Repower EU, and this year the revision of the Renewable Energy Directive, or the very recent update of the Energy Efficiency Directive. The present challenges and opportunities demand fundamental change, in which research and innovation plays a crucial role. Research and innovation will contribute to accelerate the necessary transitions and will help drive the long-term systemic changes required for a cleaner, greener, and fairer society. The European Union invests in research and innovation through research framework programs. Those have been increasing budget since the very first one, since Framework Program 1, all up to Framework Program 7, Horizon 2020, and finally, the big budget of Horizon Europe. Out of this budget for Horizon Europe, more than 35% will contribute to climate objectives. Let's now go back to Horizon 2020 and process industries. And there we find the Aspire partnership, a public-private partnership for the sustainable process industry through resource and energy efficiency. These public-private partnerships are a key implementation tool in H2020 and remain key in Horizon Europe. Through these public-private partnerships, the European Commission comes together with a private partner And together they address the most pressing challenges of Europe, also through concerted research and innovation initiatives. So the aim of this partnership was to integrate, demonstrate, and validate systems and technologies that were able to reduce the use of fossil energy, to reduce the use of non-renewable primary raw materials, and at the same time have a significant contribution on efficiency improvement. The relevance of this partnership is clear, as process industries are key for the European economy, but at the same time, they are resource and energy intensive, and as such, today they generate large amounts of greenhouse gas emissions and waste. Therefore, they must play a key part in the transformational efforts that are needed to achieve climate neutrality by 2050. This partnership received in Horizon 2020 more than 620 million euros and had more than 90 H2020 projects. And within the Aspire partnership topics, we find the topic adaptation to variable feedstock through retrofitting, within which RETROFEED project was funded. This innovation action responds to the need of updating industrial facilities to deliver on new environment regulations and to adapt to the increased variety of feedstock and at the same time improve the energy efficiency. Within a retrofitting strategy, the topic makes emphasis on the use of digital tools and advanced control and monitoring systems that allow having a high increase of energy and resource efficiency, while at the same time decreasing greenhouse gas emissions and the use of fossil resources, and also reducing OPEX and increasing productivity. And indeed, RETROFEED deals with the implementation of a smart retrofitting framework that allows for this high increase of the resource and energy efficiency in 5 energy-intensive sectors through 6 demonstrators at 6 industrial end users. Well, we will have the opportunity to learn on the achievements and results of the RETROFEED project during this morning, but from my side, I want to emphasize now the importance of demonstrating the feasibility of these new technologies at operational industrial environment, as in this way they come closer to the final industrial uptake and the final full-scale deployment. And it's actually in this way that projects like RETROFEED contribute to achieving the climate neutrality goal by 2050. Let me now jump to Horizon Europe. Process industries in Horizon Europe are addressed in Cluster 4, Digital Industry and Space, and in Destination 1, Climate Neutral, Circular and Digitized Production, where we find topics related to 3 partnerships, among which we have Processes for Planet. And as a continuation of Aspire, Process for Planet partnership aims to develop and deploy climate neutral solutions to close energy and feedstock loops and to achieve a global leadership in climate neutral and circular solutions, accelerate innovations, and unlock public and private investment. The Processes for Planet partnership in Horizon Europe in the first 2 years have received almost 350 million euros. And in the coming 23-24 work program, it is estimated to have more than additional 330 million euros. So the call for 2023, including topics on Processes for Planet, is already closed. But in September, we have opened the call for 2024 with deadline 7 February. And here we find 5 topics related to the partnership. In relation to energy efficiency and climate neutrality, we have these 3 topics. 1 innovation action on optimization of thermal energy flows in the process industry with a budget for the topic of 30 million euro. Then we have a renewable hydrogen used as feedstock in innovative production routes, which is a research and innovation action with 20 million euro budget. And we have turning CO2 emissions from the process industry to feedstock, another innovation action with a budget of 30 million euro. In connection to circularity and zero pollution, we have an innovation action, hubs for circularity for industrialized urban peripheral areas in connection to industrial and urban symbiosis with a budget of 40 million euro, and a research and innovation action, breakthroughs to improve process industry resource efficiency with a budget of 30 million euro. If you are interested in joining a consortium or in building a consortium and applying to any of these topics, I invite you to read the full description of the topics in the work program of 2023-2024, Cluster 4, or directly in the Funding and Tenders portal. And with this, I end my presentation, and I thank you all for your attention, and I wish a good final event.
Okay, good morning, everyone. Thank you for coming, and thank you for joining online. My name is Roberto Arevalo. I'm with CIRCE, the coordinating center, and I'm going to make just a small presentation of RETROFEED in a nutshell. So just a brief summary of the project. Well, as you know, our project has this long title, Implementation of a Smart Retrofitting Framework in the Process Industry towards its operation with variable, bio-based, and circular feedstock. So our project is an industrial project. We have a total of 6 demos in 5 sectors, and we have a total of 18 partners with the RTOs. Our project has lasted 48 months and has a large budget with a large contribution from the European Union. Our main objective is stated here is to enable an increasingly variable, bio-based, and circular feedstock in process industries. And we aim to do this through the retrofitting of core equipment and the implement. Okay. Through the retrofitting of core equipment and the implementation of advanced monitoring and control system, and providing support to the plant operators by means of the development of a DSS covering the whole production chain. As you can see, we are implementing this approach in 5 sectors: the agrochemical, aluminum, cement sector, ceramic, and steel. These are our intended impacts. As you can see, they are challenging impacts. So we aim at a 22% in resource efficiency, 90% in energy efficiency, and we also, of course, want to save emissions in CO2 and save costs for the companies. This is a pictorial representation of the concept of our project. In the left, you can see in the picture, there is in the center, the core equipment, which can be different things depending on the industry. It can be a furnace or it can be a chemical reactor. This core equipment has been the object of retrofitting in all cases and has also been the object of modeling by means of a digital twin in all cases. And upwards and downwards, you can see the continuation of the value chain, which is also different depending on the industry. We can have, for example, some conditioning on pretreatment steps, and downwards we can have, for example, some heat recovery, we can have some quenching and other operations. These operations, upwards and downwards, have all been object of modeling using several techniques, including machine learning. And all these models, the digital twins, the machine learning models, and other models, have all been included in what you see below, which is the decision support system, the DSS, which is being developed for this project by one of our partners. And in the left, you can, in the right, sorry, you can see some bullet points, which are the core retrofitting equipment, improving the monitoring and control system that is also linked to the decision support system, the development of new sensors, some of them very new based on imaging, for example, development of digital twins, as I mentioned, the development of the decision support system. And we point that our solutions are all aiming to TRL7, so they are already working in the demo sites. Now I go to a very brief summary of each demo. There is no sorting in particular, it's random. We start with Asash. In Asash, they have already finished the retrofitting activities. The main goal of Asash was to increase, and they have achieved an increment of 50% in the amount of aluminum scrap that they use to reduce also energy consumption, to have a more efficient combustion, reduce GHG emission, and improve their monitoring and control system. They have done this by installing a new O2 injection system, by a new burner head design, and by new analyzers. And importantly, a new delacoring system that is already in the market. In the steel sector, we have two companies, Feno Pitini and Tenaris Silco. The goals in both cases are similar: to reduce GHG emissions, use alternative feedstocks, and improve monitoring and control system. In Feno, they have already installed and are using a new injection system and a burner modification to feed biochar and plastic grains, which is allowing to reduce the amount of anthracite that they are using, so they are reducing their dependence on fossil fuels. Similarly, in Silcotap, they are using a new feeding injection system to use alternative materials. In Fertiberia, in the agrochemical sector, the goal is to replace 10% of the currently used phosphorus sources to recover valuable materials from waste, reduce cost, and improve monitoring and control system. Here, the main retrofitting action is the installation of a new reactor, new design of a chemical reactor for these alternative phosphorus sources. In Cecil, in the cement sector, the goal is to reduce emissions, CO2 emissions, to replace the currently used fossil fuel by alternative materials, RDFs in particular, to increment the efficiency of energy and also to improve monitoring and control system with novel monitoring tools based on imaging and also other imaging techniques to check the quality of the clinker. So they have implemented already a new multi-fuel burner that is what allows them to use RDF. As I said, the image-based combustion diagnosis tool, the more monitoring systems to assess the quality of the clinker. And this has already been installed, that is already running also. In the ceramic sector, Torrecid, they aim and have achieved already savings in energy and material saving, optimization of the combustion thanks to the recuperation of heat from the fumes of the furnace, and improve their monitoring and control system also. So they have already installed the new heat recovery system, the new sensors based on imaging and oxygen sensors, and they have connected these sensors to their control system. So this was the demos in a nutshell. And to conclude, I would just like to say that I consider that this has been a successful project so far. We have faced two major challenges, which are the COVID pandemic and the later energy price crisis due to the invasion of Ukraine. In spite of this, we have managed to have 5 of our 6 demos up and running already and obtaining results. Only one demo is delayed, but they are going to complete their activities in the next months. So we can say that we have all demos almost running. Our results are in line with the foreseen impacts already, and I'm sure that they will be better when all fits in place. Several of our solutions are beyond intended TRL because they are already in the market or almost market ready. And so, as I say, I consider this has been a successful project, and I'm really happy and proud to have been a part of it. And I would like to say from here that, well, thank you very much to all partners for your work. And now I leave the floor to the demos so they can show us what they have achieved. Thank you.
Good morning. My name, as you can see, is Francisca Galindo Paniagua. I'm working for Fertiberia Group. I'm the technical director, and I'm the leader of Work Package 9, which had to do with the demo in the agrochemical sector. I will start explaining what is Fertiberia. Fertiberia is a fertilizer company, and we like to say that it's not only a fertilizer company, but we are very much concerned about environmental issues, and we got a lot of solutions, not only for the farming, but also for environmental application. For example, the reduction of NOx in the combustion processes. This is Fertiberia at a glance. Here, I won't go deeper in this slide, but you can see how many products we produce, how many people we employ, etc. Our value chain is started from energy, minerals, and water supplies to all the chain up to the farmers and also the industries. You can hear me? Can you hear me? So I can leave the micro here. These are the current plants we are running all over Spain, mainly, Portugal, and also in France. And here you can see our vision, what is our compromise with the future of decarbonizing our sector. It's all based on green ammonia, because this is a roadmap to 2035, where you can see we have reduced a lot of GHG gases up to more than 50%, but there's a gap that is needed to be reduced, and it only can be done through green ammonia, because ammonia is a raw material for all nitrogenous product, which is the main product in nutrient for fertilizers. This is our net zero project. There are many projects involved in this net zero for 2035. And we have to say we are the first company in our sector in Europe that is going this way and have done some step, the first step. But here you can see how many projects we got related to this net zero goal. In this moment, we are running 5 projects, 4 of them in Spain, all to produce green hydrogen, and from green hydrogen, green ammonia, and also a green complex in Sweden, in Luleå, based on green hydrogen to produce green ammonia, and so all green fertilizers. Green. This is our first step, which is a reality. It's in Puerto Llano. It's based on a solar field of 20 megawatt. We produce from this dedicated solar field energy for electrolyzers, and from this electrolyzer we produce green hydrogen and then green ammonia, and it's now a reality. And the last step of the reality is the new line, the new Fertiberia line, which is impact zero line, fertilizer based in this green ammonia. So I will go directly to our project, which is this retrofit for NPK, or NPK plants in Huelva. The main objective is the valorization of waste streams as alternative phosphorus and sulfur sources in Fertiberia, the mob site in Huelva. That means we are going to produce or fertilize at least 10% of the raw material based on circular economy phosphorus. We already have run some Horizon project which are based on this circular economy, which are new first, it's finished, and a parallel one, which is be first. But this is very important for us because we are going to use this raw material directly in our plant. For that, we have designed and run, well, will be run, but it has been run in a pilot plant, a new reactor, to produce ammonia sulfate with ammonia and sulfuric acid in a direct reactor to the granulator. This is very tricky because the reaction is very exothermic and produce a lot of problem in the plant. But in the pilot plant, it's been very successful because even we reduce a lot of the energy consumption. You will see that. Well, in the last slide, I showed you all the steps for this, all the tasks we done for this project. The first step was the design of the pilot plant, the basic engineering. It was done in time. The second one is the development of a digital twin. The third one is the pilot plant. It was very much delayed due to the pandemic. We suffered a lot of delays due to the construction of the equipment, and also then the running of the plant, because after the pandemic there was a big energy crisis due to the war and due to the rise of prices. So we had to stop the main plant, and without the main plant running, we couldn't run the pilot. So the delay was for more than 1 year, and well, at last we could run the plant and have very good result. I will talk about them. Tax 9.4 was the scaling up of the pilot. We could do it even before the pilot, but we finished it. Here you can see some part of the engineering. And the fifth one was the commissioning and installation in Fertiberia NPK process. It is unfinished. Part of it is done. For example, some modification in the granulator or new equipment that had to be installed. But and the main reactor that you can see on the right of this slide is the reactor, the pipe reactor that will be installed at the beginning of next year. It's already in the plant and waiting for the production to stop for a long time because we need at least 1 month. This is a compromise. We agreed with Lucia to do some demonstration as an alternative to the last task, which is the real demonstration, but using some sparkle we installed in the granulator and premixer, but the result was not conclusive because the plant had a lot of unstable situation. And these are the last retrofit result. I would like to show you it in capital letter, but I cannot boast as we didn't finish the project yet. So, but I can have some result from the pilot plant For example, we did an important reduction. We tested and proved that we can have an important reduction in energy consumption, as the plant is now consuming half tons per hour of steam that is produced in the boiler using natural gas, and also using natural gas for the dryer. We reduce this steam consumption to 100%, and we will reduce also the consumption in the dryer because the temperature of the reaction will be raised, and so we won't need this steam and lower natural gas. Also, we have demonstrated that we can replace sulfuric acid and ammonia reaction we can replace the ammonia sulfate by this reaction. In the plant, we've got a successful result. And so we can have an acidic slurry that can digest the ashes and struvite, etc., that we are going to use in the real plant. Also, the water balance was very important in this plant. We can assure that through the pilot result, we will guarantee this water balance. And also other challenges, for example, the reactor design, the substitution of energy yielding reaction, emission level, are kept and even lower than with the real plant. So these are our expected results. We are very happy with the result from the pilot, and I hope we can demonstrate it in the real plant. And this is my presentation. Thank you.
Now it's time for Carlos. Just to introduce you, our moderator of the session. So now, as you know, we are going to have the presentation of the demo sites, but the moderator of the session will be Ludo Dils, that is the advisory board member of the SPIRE. So he's going to control also the time more or less that we have. So please try to use only the 5-6 minutes, okay? But Ludo, please, if you want to introduce yourself.
Okay, so thank you very much. It was a little bit weird for me to control the timing of the speaker.
Yeah, I can do it.
I'm probably the only one that you don't know, so it was a little bit weird for me. So thank you for introducing me. So what you mentioned, I'm the former chairman of the advisory and programming group of Processes for Planet, which is the successor of SPIRE. And at the moment, I'm responsible in Processes for Planet for what we call the portfolio analysis. And portfolio analysis is, in fact, to analyze what are the results of the projects, how can we use them, how can we proceed with them towards full deployment, how can we multiply them, etc., etc. So really to see how we can move on with that in a way that we reach our objectives of 2030 and so on. So that's really the job I'm doing. So in that way, I will also ask you later on in the panel discussion some questions. When I look to the results of RETROFEED, then I see about 6 main topics, which are the burner, design of multi-fuels, etc., retreatment for pure feedstock, different feedstocks, biochar, plastics, RDF, etc., waste that is recovered, online monitoring, and flue gas recovery system. When I look to that, it could have been already 6 projects. So first of all, I would like to say that I really appreciate the efforts that are done in this project. It's a huge amount of work. On top, it was in the middle of several crises, and you managed it. So it's really fantastic to see how a group of different big industries could collaborate together with some academic groups, etc. So it really makes sense that it really is a very successful project. Nevertheless, of course, we will look forward to the future, and we will see, can we reach the objectives of 2030, and how can we move on to the objectives of 2050. And part the panel discussion will be about that. We will not look backward, but we will look to the future, of course. Having said that, I would like to ask the next speaker, which is Matteo Cini.
No, we have changed a bit.
You changed the program?
Yeah, because
yeah,
sure. Yeah.
No problem. And from now on, please keep more or less about your 5-6 minutes.
Okay, I will try. Thank you very much. Good morning, everyone. My name is Carlos Concepcion from Torresid. First of all, I would like to thank Roberto for making the introduction of Torresid and the work done in the framework of the RETROFEED project. Okay, Torresid has been in charge of the ceramic demo within the project, and the overall objective was the retrofitting of equipment and implementation of advanced monitoring and control system, allowing the use of variable feedstocks, improving the overall environmental performance. Why is this important for us? It's important because the improvement and innovation is already written in the mission of Torresid, which is to provoke the change through global leadership innovation of process and products, creating new solutions and technological and fashion trends. This is why the innovation and improvement is important for the company. You may ask, who is Torresid? Because some of you know Torresid, but not all of you. We are a globalized multinational family founded in 1963, supplying products to the ceramic sector, and nowadays ceramic, plastics, textile, and glass sector. We supply a lot of different products. I don't want to go through all of them. Basics, frieze and glazes, enamels, ceramic decorations, injet inks, pigments for plastics, glass decoration, construction materials, textile decoration, and so on. The company has 29 subsidiaries throughout the world, and 7 of them are located in Europe. You may ask now why it's important for us retrofit. Retrofit is important because we are an energy-intensive industry. We use more than 25,000 tons of natural gas per year for the melting of the frieze. Not only of the natural gas and the CO2 emissions, but also we use a lot of water. More than 500,000 cubic meters per year are used in the process, and we have to fill again this water. And also the basic product, which are the frieze, which are molten in the furnaces, we change the product every week, more or less. So we have a huge range of products being molten in the furnaces. Consequently, we produce a lot of different wastes, and we have quite flexible feedstocks. Therefore, we need to reduce the emissions, reduce natural consumption, improve the performance of the furnaces, as well as reduce all the waste and the streams involved in the process. And this fits perfectly in the retrofit project. What has been done in Torresid? This is the basic diagram of what is a smelter in Torresid. We have raw materials, they come into the smelter. We have the natural gas, oxygen, air. We get fumes at 1,300 degrees, and they go out to the exhaust. And then the molten feed comes out, is water quenched and dried. So we need a lot of gas, we need a lot of water, and we get a lot of fumes out of it. So what has been done in Torresid? We have optimized the thermal recovery of the waste heat. We have developed tailored control and sensor systems to optimize the material energy flows. We have developed a new DSS tool, and we have worked towards the reduction of waste streams. These are the 4 areas in which we have worked. And what has been achieved in the RETROFEED project? We have validated optimized waste gas recovery systems, allowing to reduce 15% of CO2 emissions. A new high-temperature heat exchanger has been installed. We have modified the burners, so we are able to use up to 800 degrees waste streams in the burners as air. We have modelized also the frieze and the composition for adjusting the compositions of the frieze to the melting conditions. Together with the partners, we have developed and validated a DSS tool. This system has allowed us to optimize the program of the frieze that are being molten. As I told you before, in 1 month, we can melt up to 15 different compositions, and we have changes. So we have been able to reduce by 50% the waste materials. We have installed novel sensors approaching a 4.0 industry. We have novel sensors for materials, for oxygen, for water, for temperatures. Down you can see 2 new graphs for water flow and water temperature. And by these new sensors, we have been also able to reduce water consumption by, what is wrong, is by 50% more or less, by 25%, sorry, for the water. And here you can also see one screen of the DSS system that has been developed by Optit. On the overall, we can say that we are very close to the general objectives of the retrofit, as stated in the DOA. Well, we have not achieved 30% of CO2 emissions, but a 50%, reduce water by 25, and develop and validated the DSS tool. So in overall, we can say that it has been a quite important project for ReSeed that has allowed to reduce overall the impacts of the company in the environment. And thank you very much for everything.
Yeah, good morning to everyone. I'm Daniel Oliveri from Ferreira Nord. I'm gonna present the results from Feno demo sites, and of course, this is an introduction of our production flow. We have an electric arc furnace in order to produce carbon steel. And we have, of course, other steps, which are leather refining and the continuous casting machine, as you can see in the image below, with 6 lines. We produce almost 5,000 tons of liquid steel per day, with an annual production 1.5 million tons of steel. And we produce almost 80% of construction steel and 20% of drawing steel. And the main charged steel scrap, is 170 tons per heat, and we produce 150 tons per heat of liquid steel. These are the activities that we carry out in our retrofit project. And of course, we had several trials with the injection of several feedstocks and materials inside our furnace. And we had also trials with burner using polymers in our furnace, as you can see in the image below. And of course, we had sent the slag samples to RENA in order to have the thermal buffer test. And in the right part, you can see our injection system, which is a silo, and with a capacity of 100 cubic meters. And we are able to inject around 40 kilograms per minute of material, and of an average consumption of around 4,000 tons per year of materials. These are the results for the injection system. And we tried several materials, which are polymer, tire grains, of course, blended polymers, and at least biochar at the end. And we had, of course, a huge trials number of tire grains. And one important aspect is the biogenic content of the material, since you have almost from 25 to 35% with polymers and their grains of the biogenic content, carbon content. And one important aspect is biochar, as of course, all the carbon is coming from biomass. So these are results in order to compare 2 years. And we can see in the first year, the 2022, we had a higher substitution rate, which means we were not able to manage the material properly. But in 2023, we enhanced our ability to inject these materials. So we lowered down the value from 3 to 1.3. Those are, of course, the specific value of the materials compared to the liquid steel which is produced. And of course, one aim is to have this value 1, which means that anthracite can be replaced with a 1 ratio with tire grains. But also one important aspect is that even if we are not using alternative materials, we are paying more attention to the anthracite injection in our furnace. These are the biochar results, of course. And we had several trials in these 2 months. And we can see that we lowered also the consumption of the anthracite compared to the tall grains. So as I mentioned before, we pay more attention on this aspect. And of course, we had trials with biochar with a ratio of 1.5 of the substitution rate. These are our impact. So we can see we make a comparison between tall grains and biochar. And we can see that the biogenic content in this in those data is a very important parameter. And as you can see, we are able to reduce in a greater way by using biochar the fossil CO2 emissions. And this is almost a simulation of 1 year of specific fossil fuel reduction by using tall grains or biochar. We are able to reduce by those quantity the CO2 of in a 1 year production. And of course we are able to substitute 20% of anthracite. These are forecasted data. And we saw better results with biochar, so we are pretty confident that we can replace 30% of anthracite with biochar. And that's it.
Here. Good morning, everyone. So I'm Mircea Blaga. I'm going to represent Silcotube in this short discussion and journey we had in the last 4 years together. So several words about Tenaris Silcotube. We are part of Tenaris, which is a global leader in seamless pipes production and related services. In Romania, we have, I would say, an integrated technology being present in several places. But I would mention here only the 2 big integrated plants we have, one in the north part of Romania, where we are, actually, I would start with the south, where we are present and we are producing steel, electric steel, which is very important detail, and we will see it over the presentation. Then the north part of the country, where we are rolling the bars that we are casting, transforming them in pipes for serving 4 main technologies and industries all over the world: automotive, energy, power generation, mechanics, so on and so forth. Then around 2,000 employees at the level of Romania. We have a very clear target, which is 100% connected with the RETROFEED and everything we were trying to do in the past years, because we have a big commitment in front of our stakeholders at the end of the day, and our community, to try to reduce by 30% the CO2 emission by the end of 2030. So of course, this is not possible alone. So we have to involve all the partners and providers and everyone who's playing at the end of the day this beautiful game. And it obviously is not possible. I mean, it's possible, but with certain challenges, which is try to use as much scrap as possible, because at the end of the day, scrap is the material which is less generating CO2 versus all the other alternative materials of the market. And then energy efficiency, of course, try to bring new materials. And here was one of the objective of Silcotube, to try to transform. And I think this is very important, and I was always talking about it. We want to transform wastes in byproducts and raw materials, and I think this is very important also for the circular economies and for the next years to come. So this was pretty much our and is our objective. Then this is a image of our performance by the end of our financial year in Silcotube, June 23, on which we can say we are proud to say that we were able to reduce the CO2 emissions with 30%, not in 2030 as was initially targeted, but in 2023. So this is a very good progress for us. And how was this possible? By bringing more and more scrap in our process. I mean, becoming more present and trying to collect and to prepare it as good as possible, reducing electrical energy. And we reduced with 10% the electrical energy in the last years. We have a 93% waste recovery rate. Our water, for example, from the process, it's 96% recirculated, and the 4% it's not, I mean, it's lost, but it's lost due to vaporization because we are still working with hot metal. So part of the water is getting vaporized. 97% recycled content in our steel, and of course, 7 alternative materials integrated in our process, and 2 of them were targeting within the RETROFEED scope. 2 short words about the electric arc furnace technology. Tenaris is using only electric arc furnaces, so we are producing around 4 million tons of steel per year only by electric arc furnace. Electric arc furnace is by far the cleanest technology available in the market when it comes to the CO2 emissions. And here we have some interesting figures because, for example, 1 ton of recycled steel, it's saving 1.4 tons of iron ore, then 1.5 tons of CO2 emissions, and so on and so forth. And this is what we are trying to do. And here is the footprint of Tenaris Silco 2, because we are recovering and recycling more than 640,000 tons of scrap per year. Then, within the RETROFEED boundaries, we try to, as I was saying, we try to identify on the market some wastes and furthermore transform them in raw materials with in order to enhance the circular economy, to reduce the CO2 emissions. And this was pretty much what we were able to get, just to have also an idea about the type of materials we are looking for. So this is a picture of tires and then of plastics that we were looking on the market and trying to transform them after various processes in good and reliable byproduct for our process. I mean, raw material, I would say, for our process. Each material has its certain characteristics, some of them very challenging for a steel producer because there are some elements which are nocive for the steel quality. But we are proud once again to say that at the end of the day, we were able to integrate the materials. This was pretty much, and I will not spend too much time on it, this was pretty much the long journey we had together with all the collaborators. And actually, I take advantage to thanks to everyone who was involved on this, because for us, as Tenaris Silco 2, this was the first time when we were in this kind of project, and we were impressed by the complexity of the activities and all the processes and all the partners connected to one single technology at the end of the day. So it was something that I just want to express my personal opinion, that it was something that I was not expecting initially, but very impressed at the end of the day. And once again, thank you very much to everyone. Then this is the performance we obtained so far. We have the 2 materials, the rubber and the plastics that we have seen previously, with certain challenges and still subject of several developments, because electric arc furnace, it's not so easy to integrate new materials, especially for the safety of the process. We are still working with liquid steel at 1600s, over 1600 Celsius degrees. So we have to be very careful. We have to take care of our people at the end of the day. So this is why we are making good but small progress toward the integration of these 2 materials. I would stop more on the plastics because in plastics we were able to integrate it faster than we were expecting. So, and also with very positive results, considering that at the end of the day we were able to replace 100 kilos of anthracite with 150 kilos of plastic, so almost a ratio 1-to-1. But again, plastic taken from I mean, we are talking here about a material which cannot be reused or recycled anymore. So it's a waste for our environment, and now it's a product for our process. And this is pretty much what we were expecting at the beginning and what we we were able to obtain. So we are present in the circularity and encouraging continuously the circular economy. We were able to reduce the CO2 emissions, and of course, the resource conservation. This is it from my side.
Hello, good morning, everybody. I represent here Cecil. I'm Angela Nunes, and it's a pleasure to be here with you and to share what we achieve with this project. So let's start. What is Cecil? Cecil is a Portuguese cement group. We are a little bit spread all over the world. We have been founded in 1930, so we are an old company at the moment. We have about 2,400 employees, and we produce about 10 million tons of cement per year in the overall group. We are also in the ready-mix aggregates, mortars and binders business. And our demo site is cement plant Maceira Lis in Leiria, in the center of Portugal. So I would say that our goals and is directly linked with our roadmap and our decarbonization. You know, cement is a producer and responsible for a huge amount of CO2 emissions. And we are really committed to reduce, and our CEO signed up with, together with GCCA, the commitment to be and to achieve neutrality in 2050. So for us, all the issues that allow us to reduce CO2 emissions, it's our focus. So decarbonization for us is a priority. So that's why this project is so important for us. Because the goal is exactly that, CO2 emissions reduction. And you would say, how? Well, you know that in cement, we have two sources of CO2 emissions, one linked to the combustion process itself and another linked to the process due to the calcination of the limestone. And that one is very difficult to avoid. But in the combustion, we can do a lot. And so our focus in this project is directly linked with the combustion. So we wanted with this project increase and replace fossil fuel and increase the rate of alternative fuels. We already consume about 50%, it's our substitution rate, but we want to achieve 100%. But these alternative fuels are relatively poor in terms of energy. It means that we need to complement them with something else. And that's why we are looking for a strong new fuel, and that's why we aim to go to the green hydrogen. So we need to complement the RDFs, the tires that we are using, and we still have, as I said before, a rate substitution of about 50%, but we need to go higher. But somehow we need to complement this energy, because to achieve a good clinker quality, we need at least 450 degrees Celsius. Otherwise, we don't achieve a very good clinker quality. So for these high temperatures, we need something else to compensate the low specific heat of the RDF. So that's why hydrogen is so important for us. So for this, we feel that we have a lack of information on our monitoring system. So we need to improve our control systems and our monitoring of the line itself, of the overall process. So that's why this project is so important, and these are our main goals. So replacing fossil fuels, saying again, and increasing our knowledge and our systems for controlling and monitoring the process. So how we intend to do that during the project? Of course, a new main burner design and the digital twin is of the most important. New sensors, because as I said, the lack of information is huge, so we need more information. And this information will help us to validate the models. So this is really a very important step. And of course, improve the combustion process control and implement a DSS system for operation. So here in the right side, you see our line and the new sensors locations. So these sensors, a big part of them, and as Roberto said before, were developed within the project. So you don't find them in the market. It's quite new, and they are installed and they are working. So, and we are now getting a very good data that allow us to validate the model and to integrate this in our own system, control system. On the left side, you see the modification that we run in the main burners. So we have now a satellite burner that is already installed, and we get now the first drills. And we go in and jumping directly to the results. You see here that the annual average of 2023 of substitution rate, as I said before, around 50, so 49%. And during the trials, we found that it is possible to increase the rate from 13 to 34%. So in the best period, we have a 34% increase, which is also very interesting, a reduction on thermal consumption of about 5%. So, of course, there is another good news. There is no changes in clinker quality, because this could be a risk when you increase a lot and so quickly the substitution rate of alternative fuels. You may lose quality in the clinker. That was not the case. And we clearly see that we get a very high stability in the kiln and in the flame. So this is really promising for us. So this leads directly to a reduction on CO2 emission in the combustion phase of about 7 to 11%. So we are really confident that these results are sustainable and we can go further. So we will continue the tests and to a final decision of implementation, because, you know, we are dealing with big volumes and we need to be very sure. But until now, the results we get are really promising. So I would say that our impact is basic process optimization. And with this, we really reduce carbon footprint and energy consumption. That is proven already. We improved productivity, so we don't have so much stoppage during process. So this, of course, is directly linked with the energy consumption, but also with the productivity. And we expect to improve clinker quality, because the stabilization, when we really deal very close with all this information, we for sure stabilize the kiln at one level that clinker quality along the year. So the standard deviation of the main parameters that we have to control in the clinker for sure will be reduced. And of course, we validate that it's possible the use of green hydrogen, yes, and the development of machine learning models for improving the operation. And we want to replicate this for our Cecil kilns and other companies, cement companies, you know, our colleagues. So that's it. Thank you so much.
Thank you all for participating today. My name is Tutku Özen. I've been working in Asaş for 5 years. This project also important for aluminum sector and Asaş. I will be mentioning in my presentation, but it's more crucial and important for me too, because this is the first project in Asash I have involved from the beginning and till the end. And I'm very glad to show you the results of the project today. So Asash is an aluminum company founded in 1990 in Istanbul. Today it has over 3,000 employees, and all of the production plants are located in the Sakarya. Also, we have a head office in Istanbul, and a logistics center in Neuwied, Germany. It is working in 5 different areas. One of them is aluminum extrusion production. The other one is flat rolled products production, roller shutters, steel shutter systems, PVC windows and door systems, and finally, aluminum composite panels. With all of these production plants, as I mentioned, are located in the Sakarya. The retrofitting actions for this project are carried out mainly for the extrusion sites, cast house, and the alternative feedstock has been located in flat rolled products production line. And this is the Asash GmbH in Neuwied, Germany. We are adding value to for helping creating better future. In the retrofit project, we have, as you understand from its name too, we have retrofitted the furnace and we have enabled new alternative feedstocks. In this project, as you can see, we have, as a pilot plant, we get the 4th melting furnace in the extrusion sites cast house. Also, in the aluminum sector, normally usage of the painted, lacquered, or oily scraps is not possible due to the emissions. So, in order to make an huge scraps recycle in the production sector, we should be able to make it pre-process them and then able to use in the melting furnaces again. So a pre-processed lacquering system has been established. To be more detailed, in the retrofit project, the new burner development integration has been achieved. Advanced monitoring and control system integration, oxygen injection system integration, and decision support system integrations has been done. As you can see, this is the new burner. It has been developed with the safety simulations carried out by IEN. Also, oxygen injection system increases the oxygen amount which is below to the furnace, and it creates a better burning efficiency in the furnace. A monitoring and control system integration yielding more controllable and more monitoring of all of the production plant. And finally, decision support system has been tried, and I believe that it will be very efficient for all of the production industries. For the alternative feedstock, here you can see the delacquering system. The delacquering system development and the integration has been carried out in the retrofit project. As you can see in the last image in the slide, the machine and the delacquering system enables lacquered painted scraps to uncoated ones, and that can be fed into the furnace. To be with the results, I just quickly passing, so I don't want to show the video because it's a little bit long. This is the main production actions that we have carried out with this project. We have also not only increased the natural energy efficiency, but also increased the usage of alternative feedstocks. By this manner, these are the results and these are the goals that we have stated in the proposal. As you can see, we have achieved a resource efficiency around 57%. The energy efficiency is very close to the goal, and the fossil resource efficiency is very close. As you can see here, a greenhouse gas emission is measured upon CO2 emission. If we choose all of the carbon equivalent components like NOx, carbon, VOC, etc., the number will be decreasing. This is the best result, but eventually for the carbon dioxide case, we have achieved in one trial 75% decrease. And for the impact, as I have mentioned in the results, but we have disseminated a little of this project too in the conferences. Also, the burner head solution developed by this project is now patented and it is available in the market too. We have compete in the project competitions and we have applied them, and all of them were RETROFEED was a finalist. And also we have present this project in the Process for Planet Info Day in Turkey, which Mr. Diaz has already participated to. In the future, we have 4 other melting furnaces, and we are willing to increase the results, exploit the results in Asahi site. All of the aluminum producers are targeting decreasing the 4 carbon equivalent ratio, so they can use the curing system and these burner head solutions. Also, decision support system, digital twin, and machine learning model can be used every energy intensive sectors. And this is all from my side. Thank you.
Thank you so much for the very nice presentations. I think it's really an amazing amount of results. And maybe we can invite the speakers in front here for the next element in the program, which is the panel discussion. They are changing your background. So I would like to, so we have about 1 hour left over. I would like to inform the audience here, but also the audience that is remote, that at the end I will foresee some time also for questions. All the questions must not come just from myself, but please feel free to prepare your question and we will foresee some time for that as well. We have a few questions, and as I mentioned in the introduction, it's about the future. It's not about what you have done. It's great. We all admire you very much, but now we have to see how will we use that for the future. And so we will try to make a few questions around certain topics. And the first one is about challenges. Challenges of integrating this RETROFEED approach and solutions in your plant, but also in your plants. It means how can you multiply it in the different ones, and also how can we multiply it in other industries. And then the second point linked to that, and for me that's extremely important, is this is about energy efficiency. And energy efficiency is great because the most cheapest and most sustainable energy is the one you don't use. That's very clear. But of course you will need energy, and we have to go to net zero at the end of the journey. And so the question is, how can we use these RETROFEED solutions also when we move to complete other uses to transitions really? So I saw already a lot of things about the burners, where we start with solid waste feedstock, and then I saw at the end several mentioning of hydrogen, which is the future. We move from a solid feedstock to a gas feedstock, etc., etc. So that's the first one. The second one will be about the savings. And then the third one will be about internally in your factory, about the skills of your people, the relationship with the internal engineering teams, and also how ready is your plant for in this digital system, in fact. So this is all about internal. And the final question will be about external. It's also linked to the European Commission, etc. What about regulations? In which way do regulations support you, create a hurdle for you, and so on? So that's a little bit overview how we will do it. We will do the round every time according to your
your place, if I can say. That's most easy for me as well. But please feel free also to intervene if you want to give a comment to somebody else, etc. So maybe if I can start with the first question. So it's about the challenges. How do you, please use the mic as well. How do you see the challenges, internal, for the different plants, but also the challenges when you have to move to complete net zero? Maybe Francisca, you can start. Yeah, Francisca, you can start.
Well, this retrofit challenge is different than the challenge in the rest of the, I think, the rest of the partners. In our case, we have to integrate circular economy material or material into a chemical plant. So there are many challenges to do it. For example, for P2O5, which is phosphorus, there are some trials in some plants. For example, in the Netherlands, they tried to integrate this struvite. It's very challenging, and they couldn't do it more than 10%. In our case, our goal is to go beyond this 10%, because there is nearly nothing to resolve the problem, the challenges in circular. That's why we thought to do it through reaction. And through reactions means that we have to change a lot of things in the plant. Not only the reactor, but also what is happening in the slurry. The slurry has a lot of chemistry. And of course, as you said, the people are a little bit worried about what is going to happen in the plant, because the plant is a living one. We are recycling everything to the as raw material, and the chemistry inside is not easy to see. If you go, for example, to liquids, the slurry, you are application for granulation. If it's too solid, you are also having problem of quality and so on. So there's a lot of challenges. But in the pilot plant, we could demonstrate that we can handle, we can conduct the chemist to what we need to digest and recycle all these raw material to go further than this 10%. And we are very confident with that. And of course, we've done some courses to all people, some formation today, how to deal with these challenges, and they are very much confident, and I think we will start the plant in next year, at the beginning of next year, with a lot of confidence from us.
Thank you very much. You answered already a lot of other things as well. Maybe if I can, if you allow me to ask a little bit a tricky question. On one end, of course, you want to sell as much as possible fertilizer, but I saw as a third topic in your business activity, smart farming. In which way can you combine these two about precision farming, etc., to use the nitrogen in the most optimal way to go to the plants and not to leach to the groundwater and so on? Is also the other nutrients, of course. Yeah.
But for raw materials, which are very important for us, for example, P2O5, which is coming from the side of the European Union, this is more challenging.
So what I mean is that, of course, you want to sell as much as possible, but on the other end, we need other business models where you will advise, give a kind of service to the farmers in a way that they reduce the amount, but on the other end, you create another business.
You mean?
Know that you provide the service, and not only that you provide nutrients
But service for
to the customers. Yes.
Yes, for them it's very important. For the farmers, it's very, very important to demonstrate that they are using fertilizer based on other raw material than the state-of-the-art raw material. And there is a focus on that from the European community to subsidize only the farmers that can take some step in that sense. So this is very important for the fertilizer producers to produce this kind of solution for the farmers.
Yep.
Because in other case, if they are buying the import that at the state-of-the-art producing way, they are not going to receive aid from the subsides from the European Commission. So this is a way.
Thank you very much. I think it's important to see that indeed we have to move not just from a production facility, but to something that is providing more services. Yeah.
One in Huelva and another one in Setúbal. So this is a experience that can be exported outside from the as well.
Thank you so much. As you see, we will try to integrate some of the different questions together because otherwise it is too boring, I think. I would like to ask Carlos to react a little bit on the challenges at the moment to install RetroFeed, but also to see for the future what is possible and so on.
Or 5 more agriculture incubators in Spain, as well one more in other facilities throughout Europe, which is quite easy to integrate, but we have all the technology, we have learned a lot. And it allows us to save further natural gas in our facilities as well as abroad. And the second point is the challenge in the long term, how to tackle it with the decarbonization. The main point is that we have the high temperature incubators. We already have oxygas, which also has been used. But what can we do else? We have to move to other components. You know that we have hydrogen, biogas, but these are not, let's say, industrial solutions so far. Modification of hydrogen in those sector, we could take advantage of all the technology of retrofit because it's easy. You have the 4.0, the sensors, you have the DSS, which is easy transfer. But hydrogen itself, it's not nowadays a solution for us. Hydrogen is expensive. We cannot move to 100% hydrogen. But we have to be competitive. So at the end, we think that we will end up with a blend of gases. Natural gas with oxygen, with hydrogen, boosted by hydrogen, and boosted with biogas. At the end, a mixture of all. And if we go further in time, I think the way to further decarbonize would be the CO2 storage or CO2 capture. Because at the end, we are a high energy intensive industry and we are processes that cannot be electrified. We have to rely on combustion.
Thank you very much. I like very much your saying about hydrogen. Indeed, hydrogen is expensive. Green hydrogen not fully available, so it creates a problem. But I saw in different presentations that you're moving towards multi-burners, flexible burners, etc. And then you mentioned exactly that you can use natural gas, biogas, hydrogen, and this can be done then in a way that just depending on the availability that you are applying it. And then you don't have to sit down and to say, I wait until there is a pipeline bringing 100% hydrogen to my plant, and then I will do something. No, you can move on now, and you can see what is happening, etc., and do it in function of time.
That technology that we have implemented, it's step forward because it also reduces by 30% natural gas consumption. Of course, we have to produce oxygen. cost. If you go to 100% hydrogen, you have to modify all the burners, which is also expensive, and there is not enough hydrogen. Therefore, as you have said, Ludo, I think the best is a blend, and to use the existing burners and all the supply that we have, the gases kits, and end up with a mixture of gases.
And probably if you use a blend, then you need a very good decision supporting system digitally to support this, because you have to adapt your burner in function of the mix in your feed of the burner. So I think there it really can make sense.
And also the other sensors that have been installed allow to control quite good the atmosphere within the furnace, which is also an advantage.
Thank you very much. We will move on, and we move now to Daniele. What is your opinion, or what are your challenges, if I can say?
Yeah, we face several challenges in this project. The first step is the alternative materials. Since anthracite is a proper material that works for our process, it's quite difficult to replace it. So the main difficulty was to find a proper material in order to replace anthracite. Both properties of anthracite are quite unique for our usage. So in order to find their grains of polymers or even biochar, is difficult to replace anthracite. Even if you find a suitable material to replace fossil fuels, just carbon, you have to manage it. So you should have a proper plan in order to inject this material in a certain way. So this is not only the chemical challenges that you face when you replace this material, but it's also a plant that needs to be perfect in order to have comparable results in these results compared to the anthracite, of course. And since Butini has other two facilities, Verona and Potenza in Italy, we are in contact in order to install new plants to inject materials that we had trials in our plant in near Udine. So we are facing also many challenges in order to adapt those injection system or those materials, since plants are quite complex, and it's also difficult to find the proper space to place the silo. So this would be also a problem in order to have a proper injection to be furnace.
If I can link to that, Daniele, and also several other presentations indicated this replacement of solid fossil fuels by other solid wastes, if I can say. You mentioned strongly the bio content, because then your benefit at the level of CO2 emissions is much higher than when you just replace it by tires that are also fossil origin, of course. What is the how are you looking to that? Because moving to another waste source, which is again fossil based, is it done first of all because it's interesting economically, or is it also something linked to reducing the CO2 emissions? And it's an open question. Maybe somebody else can answer as well on that.
Of course, by since that linear or exponential progression, by increasing the biogenic content of the materials, of course, we have much higher costs.
Yeah.
Since biochar is very expensive. But I think that we are facing a transition between the carbon content, which is coming from biomass. Of course, we are also trying to select proper grains with a higher carbon content from natural rubber. So this is also, it's quite complex. But I think that by studying the problem, we can reach high levels of the detail and the proper way to solve those problems. So this is.
Thank you very much. I think Mircea wants to say something.
Just to complement a bit, but in the meantime to bring another challenge in the discussion. We are pretty much part of the same industry, So we know exactly what we have to do to reduce the CO2. We also have to be realistic and said that we are not going to be able to arrive to net zero emission because we will not be able to produce the steel without any carbon. So one of the big challenges we have, and I think looking to the future, because challenges are beautiful if are achievable at the end of the day. If not, okay, at a certain moment you lose the passion and the motivation to fight for those challenges. So the looking to the future is the main challenge I see today is how we will be able to offset the remaining part of the CO2 that we will have in our processes. This is one of the challenges. I think we have some resources, we have some technology. So I think little by little we are growing together and we are having a clear idea where to go. Then the second big challenge that I see, it's more a legislative challenge, if you want. And why I'm saying that, because if you want to see the CO2, I mean, you have to go very much in detail in order to understand exactly where you have to act, you know. And I'm talking about the case of Silvertube. We are today in the first 15 steel shops in the world in top 15 in what means CO2 emissions. But then going more in detail and starting to understand scope 1, scope 2, scope 3. Some months ago, we realized, and we were very surprised, that if we would be evaluated by scope 1 and scope 2, which is our direct responsibility and where we can immediately take actions, we are in top 10 by far. So we are much better. But then looking to the scope 3 is the one which is not helping at all. And here is the legislative part I'm seeing, and I think this is very important for the future, because we are not alone in this game. We have a lot of providers of materials, raw materials, services, transportation, logistics, whatever. We have to move all together, otherwise we will not be able to arrive there. So this is somehow have to be sustained by the legislative environment. Otherwise, everyone will try to do businesses for profitability and not for the environment. So this is one of the big challenge I foresee in the future.
So I suppose that being among the best producers, it's also linked to the fact that you use electric arc furnace, because there you have less emissions compared to a blast furnace, which is starting from ores, etc. Then the question is, how do you rely on the carbon intensity of the electricity that is provided to you? Do you have there some activities, or you spoke about regulation? Let's move on in that way as well.
We definitely we will not stop here because we still have plenty of things to do. Of course, as low as you get in the CO2 emission, as difficult it is to try to reduce even more. What we are, as a company, what we are doing now, besides the technologies available, everything we have done in RETROFEED is also trying to move toward a more green energy concept. So, Romania, it's in a good position, I would say, in comparison with other countries, because we have a big amount of green energy available. But in the meantime,
that's based mostly hydro.
Hydro, we have the nuclear a bit, but mostly hydro. What we are going to do, and this is what Tenaris Silvertube is doing, and hopefully in 2 years' time we will be already having the technology implemented, is solar parks, wind farms, so this kind of sources of energy which are the biggest ones.
As we are speaking about challenges, in which way are you looking as company towards this kind of challenges which are outside your responsibility, but you depend on it? If you want to have green electrons, you need these solar parks, you need more hydro, etc. Is there an interaction with the authorities or with the energy producers, that there is an incentive really that you need it?
For sure. Solar park is not very cheap one, so it's not easy to do it. It is a legislative discussion and collaboration, if you want, because yes, at the end of the day, you need a lot of permits to start building from scratch everything. In the meantime, it's also financing. It's very important. It's an important key aspect on this, because At the end of the day, we are steel producers, we are not an energy producer. Then also the infrastructure of the country, in our case, again, I'm talking about Romania because I know very well the condition. The infrastructure of the country is important because maybe you would like to put a solar park or a wind farm here, but then all the lines are fully charged with, and you cannot use it. I mean, they will say, okay, I will not give you the permit to inject it in the network because I don't have space or place for you. So there are several challenges, but once again, this is not obviously it's not only a company or only a government who has to do that. Everyone has to sit together and find together solutions for them.
Very nice that you mentioned this infrastructure and supply chains, etc., which are outside. I repeat, your own responsibility. I think that the same thing is true for your scrap that must come to your plant. So you need very good chain that brings the scrap to the plant. So this is all linked to interaction with other companies, etc. Thank you so much. We move on maybe to Angela, and please can you give us a few words about your challenges? Can you use the mic a little bit? Yeah.
So we intend to achieve about alternative fuel consumption of about 90%. And 10% remaining, we already calculate that will be green hydrogen. And linked to your question, we are in partnership with some companies, our neighbors, glass companies, that intend also to have a mix of natural gas and green hydrogen, and with a green hydrogen producer in Portugal. So one of the solutions that we see is having these partnerships to have small grids and small hubs of green hydrogen. So we are trying to set up this in Portugal in very near Marseille. So we hope if the tests that we intend to run in the short term with green hydrogen are succeed, we intend to move on to this. So I think it's the first step, very important for us. Of course, with this, we won't achieve a net zero. And now we need to face another level of changes, and to move to the future, we need to go ahead in a second step, a more risky one. And of course, we don't see other solution by now than the capture and the utilization or storage of this CO2. The problem in our case is that in Portugal, we don't have room for storage. We don't have these facilities. We don't have this infrastructure as we do have here in the north. So we need to face the challenge. And perhaps in our case, the use of this CO2 together with green hydrogen, as we have a solar country, we have wind. So maybe it could be a solution. And that leads us to my final words on this. For that, we need the support. We need the support in terms of products, because if our product in the market has the same value of, I would say, a not so green product, so when we compare with the same cement but produced with high levels of CO2, there is no motivation for clients to move. So maybe in terms of taxonomy and the taxes system, we need to look on that. At national level, but maybe at European level, we need some support on that. And the other challenge is the framework regarding the CO2 utilization. Because by now, the focus of the Commission is very much the storage. And we should think that this solution may be not sustainable for the southern countries where there is no chance to storage, or there is a lot of transportation, which is also a little bit, in terms of LCA, there is a lot of impact, because it doesn't make sense to spend a lot of energy to capture, and then to pressurize, and then to storage and transport to the final deposits. So all these in terms of LCA, it's also something that for me it's not clear. especially in our southern countries. So digitalization would be very important, and we need to improve our regulations for that.
Thank you very much. There are a few things you mentioned, and I think these are very important points also to take with us for the future. The first one is indeed the storage, and I wanted to ask a question about that. Of course, we cannot make cement without CO2 because it's a result of the chemical reaction. And so this part of the game, which is about 50%, is really a problem in the cement business. We can make a little bit more green cement and green clinkers and so on, but it still it will, maybe we can reduce it to 30%, but then we are stuck. And so, and you clearly indicated that storage is an issue. That at the moment we only see storage, and I can also, it's also a message to the Commission, if we look to the Innovation Fund projects, many cement plants do have an Innovation Fund project, all linked to storage. Because we have I have the feeling, but now I just say my personal opinion, because it is technically feasible. But in a lot of cases, plants are too far away from deposit sites. So it's even, and then you create an imbalance between different plants in Europe. And this is really, I think, getting an important challenge. Yeah, I wanted to add something. We see that cement industry is doing a lot of things everywhere. Not very well coordinated, but if I am informed well, I think there is a very good coordination among the cement industry in Portugal. So it's really, the association is working very hard on finding solutions, etc. So I think that's already a first advantage and challenge to become strong in this discussion. You mentioned the second point, and that's the partnerships. So concerning your hydrogen, you say if we partner with other companies, it will help. And then you mentioned also CO2 use. And then I can only say then you need a partnership with the chemical industry and so on. And instead, while you are in a big industrial area, which make challenges. And I would like to bring that forward to the audience as well, that we call it INSPIRE and in Processes for Planet hubs for circularity, so that we create big hubs where you interact with other big energy intensive industries, also with SMEs is also possible, and that you try to combine the different challenges in an integrated way, that you use the heat from one for the other, that you combine hydrogen production, etc., etc. So I would like to mention that, and I think that's an important point also for the future. Yeah. Yeah. And even interaction with urban situations. And Lucia mentioned this morning, one of the calls is just linked to that, industrial hubs linked with urban situations, which is in your case not too far from Lisbon and so on. This brings me to do I say it right, Tutku? Okay. What are your challenges in Turkey?
And then the solutions that we got, but eventually we get things better. For the future challenges, I want to mention about more in the materials, right? Because in aluminum industry, the primary aluminum production requires 95% more energy than the using of the scrap. So this is a huge number. So in order to decrease this payment, 95% is too much. In order to decrease the energy usage, all of the aluminum companies are turn their goods to the using of scrap aluminum. So we should be carrying out this one Also in Europe, some of the primary aluminum production factories has been closed in recent years. So that's why all of the aluminum producers try to increase the usage of scrap aluminum. But there are some challenges to using the scrap aluminum too. For example, we are engineering automotive industry in order to increase the lifetime of the products. Also, we are making some hybrid usage, especially again in automotive, aerospace, and the other industries. So how we can get scrap in the future? This is another question that must be think in the future too. If we increase the lifetime of an automotive, how we can get post-consumer scraps to recycle them? We don't have that much bauxite mineral in the Mother Earth, but maybe in the future we don't have enough scraps to produce more. With the increasing demand of the metallic materials, maybe it will be a problem. Also using hybrid materials. For example, we are using aluminum with steel and composite materials. So it is very important to separate them, to be enable all of them to be used again. For example, I think my partners in the steel industry will agree with me too. It will be very non-efficient to use steel scraps in their furnaces with composite material in it, aluminum in it. We should sort them. We should separate and sort them. So in the future, I think recycling industry should work hard to separate, sort, and make digital systems for them.
Thank you very much. I think you mentioned very strongly this advantage of using scrap. Marcia mentioned it as well. So this is extremely important. But then we rely on one end on these supply chains. But you mentioned, and I was really intrigued by one of your slides, this the quality of the scrap, and you presented this delacquering system and so on. And isn't it that really the preparation of your secondary feedstock is extremely important? And isn't it that this is an aspect that is a little bit abandoned, not yet fully developed in a lot of cases? You mentioned impurities. I like very much that you mentioned composites and hybrid materials. Everything that we are using today is not just steel or aluminium. It is a hybrid material. It's a mixture of everything, and we need to separate it. And so it's nice to say circular economy, and we have to go to scrap use, but the scrap is very bad, if I can say, although the content of some metals is very interesting. So how do you see, but it's not only to you, Tutku, but probably also to Mircea and maybe somebody else, what can be done there to improve the quality of the scrap of your secondary resource, so that you can improve your process as well? And now you installed a lot of sensors, very important, but at the beginning you need quality. Any ideas?
Requirements. So if we continue using organic materials for coating, then we need to reduce them, delacquer them, let's say, to be able to use in the furnaces. So maybe different coating techniques, which is not emitting too much carbon dioxide to the environment, can be studied in the future. Also, in order to, let's say, separate the hybrid materials, composite materials, and aluminum, etc., as I mentioned before, maybe sorting technologies in the recycle industry can be studied. So I think steel industry might also.
Yeah, our situation is pretty much the same, but talking about different type of material. Yeah, I can give you, if you want, a practical example, because the culture in Romania of scrap is not so well developed, and indeed we are still having issues with actually two types of problems. One is the sterile material or the impurities that are coming together with the scrap. But on the other hand, it's also the content of some undesirable elements in the scrap. So as I was saying, the culture in Romania in the scrap dealing in the scrap industry is not so well developed. And the funny fact, the scrap dealers, which instead of separating, let me tell you, copper and lead, which maybe is 5 times more precious than selling it as a scrap, it's currently selling it as a scrap, which for us is a big problem. What we are doing here, we started actually, I think this year, we opened 2 new scrap collection points. So now, right now we have 4 scrap collection points in our business. This is helping us to increase and improve our presence in the country and increase a bit the capillarity. And why we want to do that? Because we are targeting areas on which we have a very good industrial generation of scrap, which is much easier to understand it and to know, okay, if you are going in the bearing industry, you know exactly what kind of steel they are using, you know exactly what kind of scrap they are generating. In one hand, in the other hand, we have our culture, which is, and we know that if we want to continue to be competitive and less CO2 generators, we have to move to scrap. This is why we are up today to 99% of our material, of our raw material, is scrap. Only 1% is pig iron. But we will eliminate, and even this 1% will be eliminated. Then our culture is totally different. So we have already the practices, we have technologies, we have big machines that are cutting and processing and separating the scrap. Then indeed, and this is my last idea here. There is one big challenge we have with the steel, which is mixed with different alloying elements that are not desirable for us. Actually, are very bad for our product performance. And here we are working with some companies which are developing some online spectrometers in order to be able to analyze continuously the scrap content. I mean, the scrap content and the elements content, and immediately separate in different piles with different of characteristics we are inputting. So this is the kind of journey we have. First, to try to get as much scrap as possible. Second, how to separate the impurities, but also how to differentiate it in different chemistries. And last but not least, because today we are, for example, for our final product, 95% of the product is moved with train, because this is the easiest, cheapest, and also the less polluting technology available. So 95% is train. Then we can go also to infrastructure, but it's another story. In scrap, because the scrap dealers doesn't have the infrastructure and doesn't have yet the culture of CO2 and of environment, they prefer to use trucks. Trucks are polluting a lot. I mean, we see trucks all over. So this is another point or challenge, if you want, on the scrap industry we have to look for in the future. And for that, we have, for example, we are in the very south of the country, right on the Danube. So we have to use somehow the small boats and Danube in order to take advantage of this resource we have available.
Thank you very much. I would like to react on that, but first, Carlos.
Yeah.
You, Danieli, you wanted to react. Sorry, sorry.
Since we are in the same market, and I want to point out just one thing, that contaminants, chemical elements which are contaminants, is not only a short-term problem, but if you have accumulation of these chemical components, chemical elements, you have a long-term problem, since in the future you will have such as copper, which is the main contaminants. You have area level in your scrap, so you have a very big problem, and you cannot remove, for example, copper, which is scrap particular, is way precious, and they cannot remove, or it's difficult to remove, let me say like that. And so we probably could have some problems for long-term scrap.
I think this is a very interesting, important discussion, but we have to go to other discussion points as well. But I think maybe we can summarize this, that we are all agreeing that scrap using is a very big advantage, but on the same time, we have a big challenge that this scrap is of bad quality. This cannot only be solved by sorting, because then we will have a lot of bad scrap on a heap, and then what to do with that. So I think this is really a challenge to have a kind of pre-treatment of this bad scrap to make it good scrap, if you want, so that we can use it. And I think that's a challenge. And I must say that in Process for Planet, we are looking to that, where we think that maybe a lot of SMEs can be involved in treating waste. Now I might make it more general, in a way that you prepare it as a real good secondary feedstock for all of your companies. Time is moving very fast. Maybe somebody can also have a look if there are some questions from the chat in the meantime. In the same time, I would like to continue with you about internal issues. You are all in a nice position in your factory that you can think about the future, etc. But the people on the ground, they have to do the business as usual. They must be performant, and so on and so on. In which way are there some issues at the level of skills, at the level of, is the engineering team fully agreeing with what you propose? And third, also, in which way is this readiness available concerning these digital and sensing systems, etc. Just to not lose too much time, the one who wants to start, I will give her the floor. Can somebody? No questions. Okay.
Yes. One is availability of these waste phosphorus contents, and the second is the concentration of these nutrients in these ashes, let's say. Because if there are not enough content, of course, it's not going to be good for the industry. We cannot take enough fiber. And the other challenge is, for example, there are not enough incineration plants in Spain to produce these ashes. For example, in Switzerland, there are a lot of incineration plants. They incinerate all the waste, and they've got a lot of ashes. But in Spain, there are places where it is not allowed to incinerate. And also, that's for the availability. And also, transport is very important. You cannot go to Switzerland to bring acids which have a very low content of P2O5 to Spain. That has no sense. So this is another big challenge. You have to live with the raw material that are around your plant.
Thank you very much. I think that again is a little bit linked to the proposal or the call for urban industrial integration, etc. So that's certainly linked. Somebody else who wants? Yeah.
Of installing the right reactor, the right way to do it, and to change the paradigm, let's say, of the people. We are going to use another raw material. This is the future for the plant, and we have to adapt. That's not so difficult to do. It's not so difficult because we have done along all the life of this sector. For example, in Spain, there were more than 30 factories producing fertilizer. Now there are only 8. They adapt. But if we don't adapt, we will die.
And you mean that the survivors are the ones that move forward?
Right.
Yeah. Okay. Thank you so much. Somebody else wants to say something about internal issues?
Success of the implementation of RETROFEED is because at the beginning of the project, we already made a core group of people, from engineers, from chemists, and from workers for the plant, as well as people from health and security, design and implement everything that was going to be done in the retrofit project. So it's the whole chain from the workers, which are on the smelters, who have to deal with the fleet, up to the engineers and the people who are in the laboratory. So it's the whole chain. And this is one of the pillars of the company, which is the human resources. Together, also, in our case, when we don't have the expertise, we rely on centers like CIRSE, that to give us this external expertise either in modelization or in new technologies.
So thank you very much, Carlos. Somebody else wants to say something? Yeah.
So sometimes it's difficult to convince them to stop, to set up new sensors and new technologies, new materials. I think that's the main secret to be succeed in this situation, is involve them very early, very early stage in the project. Because if they do understand what the benefits that come out from the project, they collaborate with us very easily. Of course, with some constraints, with their own constraints, and then to stop the cement kiln, you know, we stop twice a year, a big stoppage, so cool down the kiln. So it's not easy to have a window of opportunity to set up all this. But if we are well coordinated, if they are very sensitive to what is the benefit that comes out for their own process and their own improvements, they collaborate very close to us. And it was really very nice to feel that the secret is to involve them. In our case, at least with our culture, I would say that's...
It was mentioned several times, but I think you mentioned also this shutdown. This is about retrofitting big plants. They are ongoing all the time, and they have only some limited shutdowns a year, even sometimes only once. But these are the opportunities to make some changes. And so we have to take that into account as well. And yeah, but they need to be convinced on beforehand. Yeah. Somebody else?
Also a very short comment. Yes. Internally speaking, I don't see challenges, but I do see a very interesting and successful development story developing. Because looking backward 10 years ago versus today, I do see our operators and our teams focused on do something to reduce the CO2 emissions. So more than a challenge, I think we have to continue to grow and to encourage the mindset of CO2 reductions, and this will come by itself in a certain future.
May I immediately put this internal discussion to the external one? Because you said a few nice sentences in that people are proud to work internally to move on to make the plant more sustainable, more economic at the end, because that's the benefit for them directly. In which way is it also possible to use these elements and to use all the results of RETROFEED to go to the outside world? Because the outside world, in a lot of cases, look to your plants as mysteries and dirty plants, etc. In which way can you convince them that you are doing the right thing to move towards a more sustainable world, which will provide also economic health and wealth, if I can say, for them?
Well, in our case, being present in 4 continents with different production facilities, of course, all the other colleagues of us from South America, from the United States, they are always waiting and pushing us for the results because they want to move ahead with the same technology. So once we will be able to prove that this technology is reliable, it will be only a matter of time when they will start to implement the same technology. And I think the first colleagues from the Nalis group, which are going to move ahead with this technology, are our colleagues from Italy. We have a plant also in Italy as well. So, but we have to prove that this is reliable, this is a good for the future of our product and performance, and then they will move. Then talking a bit about the external market in Romania. I don't know. To be totally honestly, I don't know what to say, but I do foresee a big challenge in the future for the availability of these kind of resources. Why I'm saying that? Because in an competitive environment on which a lot of players want to go to move from the conventional carbonic material to, let me say, tires, plastics, and so on, the demand will increase a lot. So here we create a bit of competition, but this is the kind of competition that at the end of the day generates progress. Now, so let's wait and see what will happen.
Somebody else wants to say something about this external exposure? No? Okay. Then I would, I think the availability of resources, it is mentioned several times. We use tires. At the end, will we have enough used tires? We see also a lot of changes now that people are you are using these tires as solid materials. We see now in the framework of recycling that, for instance, there are some plants now moving on to pyrolyze the tires so that you have an oil which can be used as an energy source. We see waste that is gasified so that you have a gas and so on. So a lot of things are moving. We want to use biomass as a direct use for making plastics and so on. So this is certainly a point that we have to take as well strongly into account. Are there any questions from the audience here?
The case, the customers, if I understood correctly, are mostly concerned with quality and price of the product, and they don't look so much into whether it is produced by green means. So I would like to extend the question to the other panelists to see if they think the same, or that in some case it could be a commercial factor to be producing with, let's say, green means.
This is the question is for all of us, no?
Yeah. Well, Angela
I'm reinforce this because the market, of course, it starts to be more sensitive to the environment due to the climate change. People are feeling this, but by the end of the day, they look to the price quality. It performs as they want for the site work, so it's fine. And so we need to look at this in terms of tax, what we can do to improve this and to support a little bit more the greener products. Maybe the right way to go is to penalize a little bit the gray products. Maybe should this to improve the greenness and to have some support in terms of taxes. And little by little, the market will sustain that. I know maybe you have different experience in different countries, but in our case, it's what happened. I suppose in Spain should be very similar.
In a different sector, in fertilizer sector is different. There's a big demand of green fertilizers as is a push from the European Commission to reduce the carbon footprint of food. So it depends many factors, but one of the main factors is fertilizers. Fertilizers are very important for the efficiency of the farms, of the crops, and we cannot cut the use of fertilizer, but what we can cut is the CO2 emission producing fertilizers. So there's a big demand from the farmers, and also as an image, there's a big demand for other companies. For example, beer producers. For the Iberia have an agreement with Heineken to produce the fertilizer they are using for their raw materials, their cereals for making beers, and they are buying nearly 100% of all new green brown fertilizer. So this is something that is now in the market, this demand. It's not only a question of I want to be green and I want to have a good image just as a company, as a producer, but also for our customers. Our customers are in this way. So I think that's a good example.
I think that's exactly a very important point. You mentioned Heineken. For me, that's what I call a brand owner. So that we don't buy fertilizer, we buy beer. And so and via the beer, we want to have beer that is more sustainable. And I think that's exactly the point. And as process industry, you're all selling to brand owners and to manufacturing industries and so on. And the way they want to have it more sustainable is due to the fact that we as consumers are changing. So I think that could be the driver. Good go.
So sometimes they make some pressure on the cast house to use too much primary aluminum in order to not to get any failure in the extrusion process. Because increasing the scrap payment sometimes causes iron content increase or any other undemanded elements contents increase in the alloy. So it causes sometimes failure. Thus, we should be more let's say, informing them about the requirement. Also, the real customers doing something like that, both for the governmental issues and the automotive and the other customer railway sectors customers requires to use more greener materials. It will be in a 5-year, I believe, they will have in the specifications of theirs to use aluminum gas, which has the amount of 4 carbon equivalent or lower, something like that. They will be added, I think. So yeah, we should be ready and inform all of the company and the other stakeholders.
Thank you so much. I think it's time to move to the coffee break. I would like, first of all, to thank the very nice panel of Francisca, Carlos, Danieli, Mercia, Angela, and Tutku for the very nice presentations, but especially also the discussion here. It's not finished. Sorry for that. We have to do still a lot more. I would like also to just summarize a little bit what we discussed and what we see. I think new business models are important. We see a short-term advantage of RETROFEED to move it to our other plants of the same company, but I also understood that there is a multiplication factor outside Europe even, so that a lot of other companies are looking to you because they think, okay, there in Europe they are moving very well, and so we will install the same system, and that's really the big benefit for the climate. We discussed a lot about these alternative resources, alternative solids, the availability of it, but on the other end also the hydrogen, especially also the blend of gases, so that your burners will not depend on availability of green this or that and so on. We discussed supply chain and infrastructure, which is extremely important. Linked to that are the if we go for waste products, we have a lot of contaminations, we have a lot of concentration issues in certain cases, and so there we need more and more pre-treatment, maybe by other companies that do the job, so that you can focus on your main activities. We discussed about partnerships and hubs for circularity to integrate everything and to make it possible that you can have a very nice collection of your scrap. It was also mentioned that you set up own scrap collection systems in these urban industrial activities. We can do this very well. And then I think linked to I forgot maybe to the waste, we have these hybrid materials, composite materials, which will be the challenges of the future. And I understood that, in fact, if you collaborate strongly from the beginning internally, that in fact this can go very smoothly, and it's a very nice process where everybody is proud to be part of the team and of the future teams that will bring you to a more sustainable production. Having said that, I would like to thank you all, and I think we move to the coffee break. Thank you.
Hello, everyone. My name is Rod Jansen from EEIP, and I've been listening very carefully with what's happened so far this morning. It's been an excellent event. Unfortunately, it's the final event. And that last session, we're going to have 3 very good presentations. We're trying to bring all of the pieces together. This last panel was just excellent from the 6 demonstration sites to see actually how creative you've been. You've tried, you try one feedstock, it doesn't work, or alternative, you try something else. I mean, it's been fantastic. And engineers are so good at that. Like you go down one road, it doesn't work, you try something else, it does work, or maybe it works a little bit. I was involved in an event earlier this year where we were talking about trying to accelerate decarbonization. And the industry people were saying, no, forget about accelerating. We just want to decarbonize. We don't even, and so we saw some of the challenges from today. We see it talked about the objectives that we have for 2030, 2040, 2050, and how things have evolved. But I work a lot with people at the industry committee for the European Parliament. They have no clue about some of the level of detail that you struggle with on a day-to-day basis. They simply have no idea about this. And so that it's very easy for them to set a new target. I was just talking to Christina about Romania that way. I worked about 5 years altogether in Romania. Oh, there you are. Okay. I didn't know which side of the room. And some of the dealings with their own government sort of saying, well, here's the target, do it. It's not that simple. And you've proven that. And also in terms of dealing with a pandemic, dealing with an energy crisis, there's always going to be some crisis in this world that you're going to have to cope with. So, and you as people in companies probably understand that more than anybody. Right now, we want to take a much more horizontal view, looking at some of the things that bring us all together. And so we have a presentation by Luca on DSS, Luca from Opted. And DSS keeps coming up all the time. And we see the whole decision making and how the need for rigor, especially as we're getting much more sophisticated, much more complex in what we're doing. Then we will have Diego come and really look at the replication potential. And this is absolutely fundamental of where we're going in the future in terms of bringing together all the pieces. Then we bring together 4 or 5 people, 1, 2, 3, 4, 5 people who aren't from the demonstration sites, but are part of the glue that's hold everything together. And where's the future? It's with all of us. I mean, we have to remember that doing this is a human endeavor. And I remember when I first started working in energy efficiency, there was a book from the United States called Energy, the Human Dimension. Well, the human dimension comes into absolutely everything, whether it's 2 people working together, somebody from senior management working with an engineer or whatever. It's all about that, and it's about decisions. And I would like to bring on Luca right now. Please, are you going to stand here to do it?
Yeah.
Okay.
Okay, so thanks, Rod, for the introduction. So what I'm going to do now is to present what we did on a most one of the most horizontal solution during the project. So first of all, I want to set the basis. So for everyone to understand what we mean with decision support system, for a lot of you here that have been part of the project for the past 4 years, you know now what it is. But for the audience online and so on, I want to set the stage. So for decision support system, we mean a digital platform or tool that helps decision-making process inside complex organization. And they do that by leveraging data and algorithms and could be used for different decision types. So we have strategic decision, for example, 5 years investment plan for companies. Long-term decision could be up to 1 year. If you have to develop budgeting, this type of tool can help optimizing these type of things. Short terms could be daily, weekly, or monthly operation. And these algorithms and data can be leveraged to support the decision in these cases, considering also the period that is very volatile, and operational decision, which are day-by-day situation where operators are starting to feel the need of having tools that can support even more their day-to-day activities. What we try to do within the project is to find a way to integrate the DSS within existing tools. So we're talking about the next level and how to really implement Industry 4.0 paradigm inside industrial plants. So we know that from the bottom, we have equipment, sensor, PLC system that collects data. SCADA system have been implemented for many decades now. And now a lot of these data are being used in enterprise management system, ERPs. Companies are developing internal solution for business intelligence. They're starting to develop more advanced solution than Excel, but now there's the need to integrate, get these big data, collect them, and run more advanced modeling, which could everything be summarized in a decision support system. Inside the decision support system, we can have, for example, different type of application for analytical studies. We can have optimization application. We can have simulation application, and these are some of the things that we developed during the project. On the right side, list some ideas of how decision support system could help future industrial plant and operators, so production scheduling, workload balancing, production optimization, considering that we are moving towards a more feedstock, a variety of feedstock-based applications. So you need tools that can help you understand when is the right time to use some certain feedstock. Before they were talking about tires and plastic grains, there would be competition on using these bio-based materials. I don't know what's the market of used tires, but I don't think it's infinite. So we need to find a good way to use to balance the cost of tires, anthracite, because as long as we're trying to improve efficiency and become more sustainable, we still need to be competitive in the market. So this tool can help a lot in optimizing the raw material. Energy management is very important. Now CO2 price on the emission trading system, I think it's around 80 euros per ton. So companies are starting to feel that they need to manage CO2 and energy. We know what happened in the past 2 years, like gas prices went through the roof. So managing energy is also important if you can basically use more flexible ways, using different type of energy in different period, considering price and CO2 impact. And then, of course, warehouse management, logistics, you can name it, you can build application and algorithms to support the operators in there. During RetroFeed, we try to build not only specific model for the core business, but try to develop a process which could be leveraged across the entire industrial chain and could be used flexibly in different industries. So we started analyzing the core process, and with the help of other partners within the project itself, we build digital twin of furnaces, digital twin of kilns, and other type of core part of the system. But also we look at the entire value chain process. So starting from the raw materials all the way to the process output of this core section. So we build the optimal raw material selection model. It's still like on a beta phase, but I think it's a good start to begin looking at raw material and try to optimize them. We build a model that could be used in the future for flexibly use energy input, so electricity, fuel. So once some of the process will be electrified, it could be leveraged differently depending on the price, market condition, weather. These are some of the things that we need to look at. And then we analyze and monitor what are the outputs. So on the output, we start to link, because the operator, they always look at the performance of the system. So how many tons of steel I've done, in what's the energy I use and the material I use. They don't really check the cost of that process. So we try to connect cost with energy consumption and material usage in order for also for the operator to understand on a longer term, if I do this type of operation, how that type of process is going to cost me in the next day, week, or month. And then, of course, one of the important part is start to monitor emission in a more structured way. So this is what we built within the process where we started to build the digital support system. And what we did is we develop a platform. So where you can integrate different type of models and see the result directly on a web application. So we build everything on a cloud-based software, so everyone can access the tool remotely, just using a standard browser. It would be a multi-user system because we realize that there are different profiles within a company. So one is more on the operative side, one more strategic. So it's a multi-user, multi-plant, considering that a lot of the company we have here were part of the project, have multiple plants across Europe and the world. With some partner, we were able to collect field data and show the measured data directly on the application. So every hour or depending on the granularity, we were able to update the historic data and see the results. And we integrate the various digital twin to simulate the process. So you can look into the future, you can run the model and simulate what could happen in the future. We built some optimization model based on the inputs that the user was using to run these models. And basically, we developed the system to integrate different type of models. So in some cases, there are more than one model that needed to be interconnected and created a loop. So the simulation could be done integrated. And then the entire platform works nicely, and we build some capabilities to automate the process. So there's a scheduler inside the application where you can schedule operations. So automatically at a certain point of the day, you can run automatic simulation. You can download the historic data. You can send a report directly to the email of or the key people that they need to see the results, maybe every hour of the day or every morning when a shift starts, maybe they want to see how to simulate the future 24 hours. And I want to see how the production plan could be done optimally. Then every hour could be updated based on historic data. So this is what we built within the project. But now I want to show you, because this part of the talk is what's the market condition right now, how these are the industries placed in the timeline of technological improvement. So here is some data that I took from a McKinsey study that it's keep updating every year. So back in the day, a lot of companies started to integrate SCADA and the DCS system. Then there was the big integration of ERP. Then the manufacturing control system and advanced process control system were integrated. But the future is needs something more. So as I showed before in the IT stack, more and more companies are starting to develop a solution based on machine learning models. Let's call it like artificial intelligence is becoming a big topic also in the industrial space, and some applications are starting to be developed specifically for the heavy industries. So here there's a lot of companies we've seen also within RETROFEED different level of IT technological development. So petrochemical companies, they're kind of advanced. We've seen steel companies, even within the same industry, we see that there's a lot of variety. We're seeing companies that now that there are technologies now to automate pretty much the entire process and to improve and optimize it. They are moving towards the curve, but we are still at the beginning of what's we can consider Industry 4.0. There are companies investing in it, but not a lot of them are already applying these type of models and algorithm directly on production, on the production process. There are pilot projects, there are tests, but tools that are really impacting production are still under development. And so what we also at the end in the past months, what we tried to establish also, it's a sort of a business model for other companies, even outside RetroFeed, to be engaged and to start using the platform that we built here, because we believe one of the important things of this project is try to go beyond at the end of the project, build something that could be sustainable, or just start to give food for thoughts for companies and developing this type of application. So the idea is in the future to build for every industry that is interested in integrating a decision support system like this one, start with a pilot project built on very specific business objectives. We need to know what are the problems that the company is trying to solve. We need to know the type of data that they have available. And then together with experts in our company, we have very good a team of mathematicians, physicians, engineers that they develop algorithms and model, but also external model can be integrated in the platform to really build something comprehend and integrated to improve the whole value chain. And then we can build together something, a solution, which is leveraging upon the platform we built here, something that could help the user change inputs and see the results of the modeling and support them during the operation. And then, of course, these in the future, we want to get into a more commercial and deployment agreement where the company doesn't need to have IT expertise. We can help them and support them through the system integration and deploy phase in order for them to have such an advanced tool without the need to build internally a big data science or IT team. So this is what we built in the past months to really replicate some of the solution and some of the ideas that came out within RetroFeed. And so to summarize this presentation, so we know that a DSS can help in enhancing operational efficiency. So you can leverage big data, you can leverage algorithm and new technology, and really move the decision-making process towards more data-driven application, particularly for those tasks that are very repetitive. So even talking about digital workforce, we mean people are sometimes doing very repetitive tasks. We can use technologies to do that, lessening the burden on those workers so they can focus on how to improve the process instead of focusing on really only how to do the process instead of improving it. And then we can look at before I think I don't remember who talked about. I take the link there. Supply chain optimization. I think Mircea talked about scope 1, 2, and 3 of CO2 emission. If you can control and you have data about your supply chain and you can optimize it, you can also reduce some of the impact on scope 3. If it's not up to you, but you can check what your supplier and other people are doing, so you can really evaluate the social impact of your operation. And then, of course, scalability and adaptability is something very important. The tool needs to be able to scale to other plants. If something changes within the plan, you need to be able to adapt to those changes. So we think in the future, given the volatility of the current market situation, every day there's big news about energy prices going up or down, material, like a war somewhere that could disrupt the supply chain of certain material. So I think it's very important to have something that could support operator and companies in being flexible and optimize the system even during very volatile situation. So I think a decision support system is something a company needs to work on and develop in the next years in order to manage the complexity and remain competitive also in the market. So thanks everyone. Now I think it's I leave the floor to Diego. Yeah, go ahead.
Decision making in a factory or in a company. In terms of what you're offering, how senior would this go to the board level? I mean, how level are we talking? You said it's not just it's key. Forget that last thing. Yes, it's not just an option, it's key to unlock, which makes it much more powerful than companies make decisions every day that don't have the DSS. And so how does it what's the added value? And how do you convince senior management of it?
Can you hear me? Yeah. Okay, so I think when you start looking at decision support system within the companies, there's also a more change management attitude that needs to happen in parallel. So companies need to start to trust models and algorithms. We've seen in our work a lot of companies that they were a little bit skeptical in adapting the decision support system because this is what we've done for 30 years. So, but then when they start seeing that the model is able to look at more variables, more you can use equation to solve some of the issues. Sometimes they lose money because they take the wrong decision because they haven't looked at that particular, for instance, energy prices. So they cannot check every day the electrical prices on the market. So if one day, I don't know, there's a lot of wind blowing and the electricity is very low in terms of price, you can ramp up production if your electrical based production. But if the day after there's no wind, you cannot keep up with the same production. So you need to be very flexible in your operation. But this needs to change the mindset of
this whole session is on the role of digitalization. And I guess if you're talking about data driven, we're dealing with a lot more data. So this has changed the whole approach that strategic decisions in a factory, in a company have to take.
Yeah, we've been around Europe, not even across the world. We've seen a lot of companies, they have a lot of data now, and sometimes they don't know what to do with it. So they read the data, they have historians, they collect data, but real decisions are always based on, I look at the data and I try to deduct things from the data. But if you use mathematics, you can really solve some small issue at a time. You don't have to solve everything, but a small issue at a time.
I just worry. This morning or yesterday, I was coming in from Paris. I noticed for ISO 50001 on energy management, there's only 28,000 companies certified globally. If we're talking about getting to net zero, we've really got to ramp up and replication in much more seriously than we have. And I don't have the answer. Hopefully some of you do, but we've got to go in a much more robust fashion. Luca, thank you so much. You're going to be becoming part of the panel. We'll have more questions from you. I want to now hear from Diego. As all of you know, I mean, Diego has been you can use the expression, the quarterback for this whole project. He's really been the man at the center of it for a long time. And we want to hear what you're talking about in terms of replication.
Yeah, thanks, Rod, for the presentation. Well, yeah, I'm going to try to explain a bit about the solution that we have developed in the project, with the replication potential that this solution have, and also some of the challenges that probably in the first panel we have discussed. But just to make a recap of all of them, okay? Because it's been a very large consortium with a very large number of demo sites and with a lot of problems that we have to face during these 4 years. Okay, so just to remark that the replication and the exploitation of the solution is a key aspect for the European Commission. Okay, so they consider that they are essential first for increasing the investment of the research and development or maximize this investment to help to drive the innovation to the market, of course, generate economic growth and address global challenges that the European people are facing. So the idea or the final remark is that we use the solution that we have developed in this kind of projects to contributing to well-being of the European Union. So the idea is that we have a better European Union using the resources that we have developed in the project. Okay, so this is the key message from the European Commission. So, well, this is a table with almost all the solutions that we have developed in the project for all the demo sites, including the decision support system in the end. Okay, so as you can see, we have a lot of the solutions that have been developed for some of the demo sites or with the suppliers that demo sites have or their own resources, but also with some of the support of the research centers and other companies that provide the technology that have developed this solution. And if you remember the presentation of Roberto, the idea is to have to pass from the trial 5 to 7. But as you can see in the table, there are some solutions that are already in the market. So, for example, the solutions in ASAS that have been developed for STEC. STEC is a technological provider in Turkey. They are the solution. They are patented. They have trademarks, so they are in the market. They have this solution in the portfolio. Also, the solution of RETROFEED that has commented, they can implement in other furnaces of the company, even in other companies. So there are solutions that they have to adapt, they have to do the calculation, but the solution is there. Or the burner that have developed HTT in Feno. So this burner that allows the use of biochar and plastic grains can be replicated in other places. So are solutions that if the customers want to be there, want to use it, they have the opportunity. So it's not something that has been finished in the project. Okay, we finished the project, that's all. No, there are solutions that they are there. Okay. Also, there are other solutions that are very, very close. So the DSS, we think that we are Interil 8. So of course, we have tested in the real solution. We are validated the solution. So almost we can say that is in Interil 9. So the idea is that all the solutions that we developed has the opportunity to be in the market. So how we can increase? So what's the pathway to commercialize this solution? So probably we have to increase the market demand. So the market, it seems that they are increasing, or the demand of this kind of solutions related to these green solutions or automotive solutions, the digital solution, they are the market. But I think that the companies, or I don't know, the European Commission, the politicians have to increase this market demand. And maybe this market is increasing, we have the opportunity to sell this solution or to show this solution to the rest of the companies. Also, it's important in the progress have horizontal results. For example, in the case is the DSS. So it's a solution that can be used in all the sectors of the project. So it's easy to replicate in the same factory, in other factories of the group, in other companies of the same sectors, even in other sectors, because we have the knowledge, we know how we can do it, and this is the way that we can transfer all the solutions to other sectors. Also, it's important to have an easy replication. So we have made an analysis in the project in order to know if possible or not to make this replication easy or not. So as I have commented, it's very easy to replicate in the same company, because normally they have the same burners, or they have a lot of burners that are similar, electric furnaces, kilns. So they have the opportunity to replicate this solution. But also in other industrial sectors, so there are some solutions that has been developed that can be integrated in other demo sites of the project. This, as you can see, mainly the solutions are related with CIRCE and AIMEN. And probably this because we are research center that they are developing the solution, and probably it's not a solution that is already in the market, that you came to CIRCE or to AIMEN. Okay, I want to buy this camera that is used for that. Okay, we can. It's not easy for it's not an easy way to sell for this kind of research center, but we have the knowledge to use this technology in other sectors, and there are sectors that can use it. Okay, so this is also the way that we can replicate this kind of solution in the project, and we have analyzed it. Okay, because we think that it's important to know the potential of all the solutions. And as I have commented, well, we have TRL 9 of some of the solutions. They are in the market, so you can see the new burner head of ASAS or the lacquering system that they are using for limiting the oils and the lack that they have the scrap. So the new injector and burner injector that have the two ways to burn and to inject the new raw materials are solutions that are in the market right now. So I think that it's important. And even other solutions, we are going to be in the market, or we'll have TRL 9 in the following months. Okay, because I think that this is one of the key aspects of the project. Okay, we have achieved this very high TRL 9. Of course, we have some barriers. So it's we have problems to achieve the market sometimes. One of them will be the legislative barriers. Okay, so we have different legislations in each country. So each country have they have adapted one of the laws of the European Commission, but each one can adapt it, and this is a problem sometimes. So sometimes it's not. For example, the use of waste is not always allowed in some of the countries, or if you want to use some of the waste, you have to, you have a lot of bureaucratic procedures. Even you have to pay to obtain the permits to use it, or to have to prepare some documents to allow the use of this kind of resources, alternative fuels, and sometimes it has a high cost. But also sometimes the transportation. So probably we have some resources that can be used in Spain, but not in Portugal, or even, for example, we are working in some other 7 industries in Spain, and they have the problem that they can use the alternative materials or the RDF from Portugal, or even from the other regions. Okay, so we have the knowledge, we have demonstrated that it's possible, but sometimes we have this kind of barrier. So we have to work in that. For example, maybe from the associations that all of you have in here in Europe, but also in your countries. I think that this is the way to try to avoid this barrier. But also we have another ones. For example, functional. Okay, we are developing solutions, but sometimes are joint solutions, and we have the problem of the geographical location. So do we have sometimes that is not the same. To have a joint agreement of the exploitation is not an easy task sometimes, and I think that it's a problem to provide this solution to the market. Yes, I have commented, the research center have a lot of knowledge. We have a lot of knowledge. We have the solution, and sometimes to arrive to the market, it's so difficult. Or even the solutions that are working in some of the demo sites needs a lot of time. Okay, for have real results, because we need large trials in order to provide that the solution is working. Because if not, if you are going to make a solution that are going to stop 1 month the production of one of the demo sites, you have to show the results that showing that these results are working. And this project, like RETROFEED, is a good way to show that yes, the solutions are working, and you have the opportunity to implement it. And also, for example, the technical. So we have you have to adapt your installation. It takes a lot of money, and so this is a problem when you want to implement these solutions. Also, the availability of resources. Okay, you are going to use new resources, new alternative materials, but sometimes they are not. The suppliers don't have enough material, or even the variability of the material is not the same today that tomorrow, and this could be a problem for your processes, for the product that you're obtaining. So this is the problems. But as you have seen in the project, you have the results where you have shown that the quality of the products that you have obtained is the same that with the typical raw materials. You are reducing your greenhouse emissions. So I think that you have the tools or the information with the project in order to avoid these kind of barriers. Okay. But also, well, we have faced a lot of challenges in this project. The first one was the COVID-19 for sure. As well, after 6 months of the project, we stopped the meetings, the face-to-face meetings. But was also an opportunity for us. We increased the number of interaction through remote meetings. I think that before the COVID-19, make meetings with Teams or remote meeting was so strange. But now it's so typical and it's so easy. If we need a meeting each week, it's possible. I think that this has been, an opportunity of the pandemic, taking into account all the problems. Okay, but also the high price of natural gas. Okay, we have problems in some of the demo sites that has been stopped during some times, but the retrofit solution are reducing the use of natural gas in some of the cases. So a challenge, but in any case, an opportunity. The lack of components, also in some of the solutions that I have developed in the project, we have the problem of the lack of components, but has been also an opportunity to find another solutions, to think about how we can change to use another component. And I think that has been also very interesting for all of you. Of course, the increase of the price of materials. So yeah, well, I think that retrofit is helping that. Okay, we increase in the impacts you have commented before. We're increasing the energy efficiency, so we are reducing the cost of the energy. Also, the increase of the resources. So, well, that has been also an opportunity for us to show the results. Well, we have 6 demo sites from 5 sectors. A big challenge. Not only for FIFE as coordinator, I think that for all of you to manage all these different companies, different countries, different people, and has been a great challenge, but what a good challenge. So we have the opportunity to show the results. And also I have to remark that we have 6 demo sites that they are selling products. The main core of the companies are selling products, and try to adapt this or make this modification in the core equipment sometimes is not an easy task, and we have made it. So that's to be also proof of the project. So just that's all from my side. Just to give that. Well, we have made a lot of solutions that are in the market or close to the market. You have the opportunity to in the project to show the benefits and the impacts, and retrofit. I hope that you help in the future to obtain your goals of the zero net production or reduce the greenhouse emissions, the energy efficiency increasing. So thanks for your work in this project.
Thank you. For steering this whole project, I'd like you to come back after, and then be part of the panel.
Perfect. Yeah.
Now we have Dusan Yakovlevich, who from EEIP, who's going to just give some little overview of digitalization and overall. Please, Dusan.
Rod, thank you so much. I mean, basically, I'll just for 5 minutes, just kind of like, look outside from the sort of like from the window, into the project. And I think as EIP, we are kind of well positioned to do this because we're not for profit organization working to promote industrial energy efficiency. And I mean, our tagline, has been from the start, energy efficiency is connected, but maybe that's a bit outdated because now it's, we talk a lot about energy transition, and energy transition being connected. But just listening to the previous speakers, and Rod, kind of doing a riposte to your introduction, when you said energy, a human perspective, when you look from the perspective of sort of automated decision making, maybe humans are the problem. So maybe it should be like, the energy, post-human perspective. And I mean, EIP, historically, we've been working, really on this kind of like edge of the technologies, trying to see, what could be kind of the key enablers to drive, this energy transition for manufacturing industries. And we work in electrification, digitalization, virtual reality. Now on gamification, hopefully, you're going to do you've done the quiz already. I'll just basically, I mean, very quickly, this is sort of very complex world of the discussions which are external to our discussions about energy efficiency, energy transition, because the EU and the IEA have been driven lots of discussions about this. I mean, there are multiple names, from IoT to Industry 4.0 to Internet of Everything, all kinds of things. And this is really kind of key issue for what we see, something that we can trigger and enable sort of overall, energy transition. And the challenges that we meet for the industrial energy efficiency are pretty much, kind of similar challenges to other sectors, from kind of buildings, transport, or even kind of, the sort of general sort of city operations. I mean, interestingly, what Luca was saying, I mean, we have this kind of jump of the gap, between we have within the project, we have this DSS, which is a decision support system. But on the other side, we're talking about data-driven decision making, and kind of reflecting what we said about humans. I mean, looking, how much actually, we can kind of move out from this support, to sort of automate, this decision making. Not that, we want to lose jobs, but in a way, this could be something that can kind of like level up progress, into industrial energy efficiency. So, I mean, this is kind of, I just outlined, sort of few things. I mean, as I said, these are sort of very much across the board when it comes, to data operation. I mean, IEA, they just published a paper 2 weeks ago on this kind of 5E challenges, and it all comes, about kind of trustworthiness and the volume and management. And Luca, as you said, I mean, people are getting data, but they don't really know what to do with it, and they will actually never know what to do with it. We have to think of a systems that this data can actually be optimized and can be used, to drive the energy transition. The last one is quite interesting, the value, and there has been lots of discussion of its value and value starting. I mean, what is the worth of this data? I mean, obviously we, as manufacturing companies, we focus on our own products, but if we are moving into something which is kind of data acquisition, it's the same with an other resource. If you think about resource efficiency, you need to think about kind of some form of data efficiency, and then you need to value it, you need to price it. And these things are very early into discussions, and we are very much looking forward to the European policymakers and how actually can they drive this the broad range, of things, into, kind of something which can support like industrial energy efficiency. So the value is the key. And then finally, I mean, the whole presentation is talked about as like a digital decade, and this is from the EU, paper from the DG Growth. And basically, I mean, we are very low, ambitions are very high. This is specifically for the industries, about kind of like a digital readiness, a digital transformation. But what was interesting for us, that with such a wealth of these discussions, only when I was doing research for this presentation, actually, I found information about this digital decade. So it shows, there is a lot of discussions about the future of, post-human future, but these are not really connected. So, basically, I mean, our message is, like the energy transition has to be connected more. Rod, I hope that's good.
Thanks, Dusan. This is excellent.
It seems very strange that for this project, we have 29 minutes left. Okay. And I'd like to call all the people, the panelists, okay, whose names escape me right now, because they're right
There
here.
you go, they're here.
Oh, here they are. So Attila, Francisco, Yaroslav, and Sofia, could you please come up? And also Luca and Diego and Dusan. I mean, I want you all here. And
so maybe you can invite Roberto, that really can also with us.
Roberto can come. I mean, I'm happy to have everybody, okay?
I will stand with Rod.
Okay, Dusan will stand.
He likes humans, I don't like.
Now, I mentioned the human element of it, and people asked me last week, what questions are you going to ask? And I said, there's only one question I want to ask you. And that's, from this project, what motivation and what increased capacity have you been given to take you forward, that you're going to move forward in this whole field? What's come to you from this project that you're going to take forward into the new phase of your career? So we can start right here. Oh, here we go.
Thank you. There are a lot of things happening in this project, and I think something is that we realize that we're really part of it. So much things have happened. We have gone through crisis, and some of the demo sites have to change their feedstock delivery and have to stop due to crisis of energy. And this is the future. And it has really pinpointed how important it is to work with flexibility and resource efficiency. So it's, yeah, we have really realized this during the project.
So how have you grown in this?
It's in that sense, it gives motivation. We know we are on the right path.
Okay.
And one thing from our institute, the Environmental Research Institute of Sweden, we have worked a lot to develop the social life cycle assessments in this project, together with the demo sites. And this is really something that is emerging and coming up.
Maybe we'll discuss that over lunch or something like that, because I'm fascinated by this area, you know,
yes,
this whole social side of it. Because again, it gets back to the human side of what we're doing, okay?
Yeah.
And I'm going to keep this microphone because you're going to pass that one down.
Yes, I have to say, I myself and my colleagues from Germany, we learned a lot from this project. First of all, we were quite aware that competition is fierce within these industries. And if you lose the pace, you will probably not exist as a company or as an industry, probably in 5 or 10 years. Everybody goes for greening, everybody goes for digitalization. That's the main topic for today. And what I was just seeing as a real learning to see how small steps, even baby steps for acquiring a few more percentage efficiency rising here, only a few percentage of saving energy there would count on a global scale. So I was quite amazed to see that this is something that really counts for these industries, and probably this will be their survival. If I can use such strong words here on the long term, but for us and for myself, the personal point of view, it was the learning from this project that I gained.
Excellent. Okay. Now let's see what your neighbor says.
Okay, so my name is Jarek. I'm from the IEM, which is the research institute and technology provider. So as we were involved mainly in the retrofitting solutions development and also digital twin and DSS system. So what we've learned from the project is that how the industry, the furnaces operate, and how they are controlled, and what are the inputs and outputs from their operation, which is crucial to understand how to build up later on for example, digital twin for them, and this shown us that this is let's say right way to develop those digital solutions for industrial furnaces and so on. But it's not an easy task. It's a quite tough and long-lasting work, and it requires, as was also mentioned by Luca, a lot of data. And this data has to be also reliable, as Dusan said. And this we found that this could be, let's say, that some focal point for those solutions, for digital solutions, the data. What is needed is a lot of data, and the data has to be reliable. Right? And what we want to encourage our partners is to maybe look to install more sensors. They are relatively cheap, but they can provide the necessary data which can be later on used for developing digital tools.
I'm glad you mentioned that, because I was talking to one of the demo sites, and they complained that they hadn't put enough sensors in, that they didn't have enough quality data. So just to reinforce exactly what you said, and partially it's because of the pandemic, partially it's been a whole bunch of reasons why they didn't put as many sensors as they wanted in.
Yeah.
But I mean, this is a whole new world that we're talking about now.
Yeah, but this is crucial actually.
Yeah.
Without data, without reliable data, the tools, digital tools are not predicting the outcomes reliably, and this is actually it cannot be used on the daily basis, and this is what is necessary.
I mean, these are important messages even for the European Parliament as they're developing new policies and things like that. This is very good. Luca, please.
So what we learned starting from the beginning of the project is how complex some of the processes are, and not only the process to make the product, but also how complex the organizations are. Right? Because as Jaroslav said, like data are important. Sometimes we found that the data that we needed to build the models are in another department. They're managed by other teams. So we needed to collect data from different figures within the company. And there was not a good way to a data management, a way of collecting all the data that we needed. So for instance, electricity and energy prices are in one database. Process, it's in another area of the company. Maybe that's a good way, but companies, they really need to start building data infrastructure in order to leverage that. On the other hand, we found out that there's a huge opportunity in the heavy industry space to build application and models to improve little by little the efficiency and improve the sustainability of some of the processes.
We have a member of the EIP family who's probably one of the top energy management people from Denmark. And he says we need to do much more on data planning, and both energy and non-energy data. We've got to understand it much more rigorously than we've ever done in the past.
I mean, what we learn is not the problem on the front end side, talking about software, but the back end is probably the most important part.
Excellent.
Well, good morning. My name is Francisco. I represent IMEN, that I think is for sensor deployment. I think that what we have learned from this project is how complex are the processes. I think that now we understand better their needs. It's not so simple, you said before. For example, introducing new sensors. It's not so easy. You have to make something that is robust. You have to find solutions to integrate them without disturbing productions. Planning, you have to, and then you have to have variable data, and that's the most important point. And that's very important because we have progressed in the creativity level. We have to find some modular solutions. We have to find some robust solution without disturbing and modifying the performance of sensors. And we have to taking into account that this is a previous step before implementing machine learning models, for example, that has been discussed right here. If you don't have reliable data and a huge amount of data, you will not be able to have robust predictions. And this is something that is very important. We need data to have good models. And if you go for more simple approach in machine learning to more sophisticated, you have differences in number of data from tens, 20 to 30 data to several thousand data. And you need that data to make reliable models. That's the most important policy. So introducing new sensors is important, but it's not, let's say, so simple because it must be reliable, robust, and withstand your process for a long time. So,
but if we're dealing with a steel factory in Slovakia, how do we explain that to them? How do we get those ideas across to them that this is the new world, this is where we have to move? And this is a big challenge for all of us in this room in terms of how we're going forward.
I think that is no secrets. You have to have a lot of communication, interact a lot with the factory to try to explain how it's important and how we can interact, integrate data. You have to find solutions with the factory people. You have to, I would say, find creative solutions, modular solutions, and establish with them the methodology. But for each cases, methodology would be different, I think, because problems are different. You have high temperature reveals, a harsh environment for sensor in steel industry, but in cement industry, our greatest enemy is the dust. And for optical and visual system, it's a very great enemy because it's something you have to avoid to damage your system. So there is no, I would say, no secrets. The only secret is to interact a lot with the factory. That's, I think, the way we have done it. Okay.
So maybe I can add to this.
Okay.
Yeah, at the beginning was mentioned by Diego, and that what is important here for the implementation of the solutions is simply the demonstration that those solutions work. So simply as that, and maybe as complicated as that. Because if we cannot demonstrate that for example, DSS system works at some place, it will be pretty difficult to convince anyone to implement it. Simple as that. Thank you.
And so I'm Jaroslav Brana from HTT. And for me, the most important point, I was involved in the designing of, let's say, injection membrane technology for the steel plant of Renault, and with the primary objective to reduce fossil materials like carbon and natural gas as well. The most important point for me is what I learned. I'm convinced that that technology works. It has potential to work. It is much harder to implement than I thought at the beginning, and the challenges which we faced during this whole project were actually also different than what I thought at the beginning. Second point which I learned to replicate this technology and expand it to other clients, other customers, other plants. There is a lot of legislative barriers which are still present, and it's not, less or more, it's not harmonized at all. Because, for example, for tires, even within the country, when we talk about the usage of tires like alternative to anthracite coal, you can do it in the cement industry, but in the steel industry, it's not so easy. It's not the same legislation. So if you want to use it for calorific value in the steel industry, it's many countries it's not allowed. If you have a same cement kiln in the same country, you do the same there and it's no problem, but if you do it in the steel factory, it's not allowed. So there are a lot of barriers other than technicals. So that's and we face it now because the similar thing which we did together with Fano, we try to do now in Austria and Germany, and they have to go and ask again for our local authorities to approve it, if they can use that material or not, which was already used before in somewhere else, you know. So this is the thing which you know, I see that this is besides the technical challenges, which are, you know, many, but there are also a lot of, let's say, bureaucratic obstacles which basically make it much harder to replicate the solution.
But other than creating awareness of these problems, is there something that can be done at the EU level, or is this really a national and subnational issue?
Well, I don't really know what is the, you know, this legislation is quite complex. I do know that when we ask our customers, can we do this? We show them what we have done, what we tried to do. And they always said we have to ask like the local authorities. And for example, in Austria, they said, okay, what we, I know, for example, for the things like the tire grains, which can be classified as a product when it's after it's recycled and crushed and cleaned. In Austria, they said for us, it's always classified as a waste. So it means a whole different process if you want to use it. So that's, and I don't know if that is this could be better harmonized on European Union level. So basically, if that material has some approval to be used in some way in one European Union country, why it's not the same for other countries? So it's very, for me, it's very much still like a local country's legislation is let's say for a lot of these plants not harmonized with some European level of legislation. So that's.
I just don't know whether this is an issue for DG Grow or DG Environment, or certainly not DG Energy normally. So I don't know where the problem lies and where the solution lies. It'll be interesting. This is going to go beyond retrofeed. There's no question about that. But it's something that has to be solved if we're trying to get to net zero by 2050. I mean, these are things that are going to have to be solved. And it's actually quite good that retrofeed is identifying, you know, as much as anything. But now we've got to not just identify it, but we have to explain it to a wider audience that these are really barriers that are holding us back. Diego, you've had a few years on this. What have you learned? What have you gained from this?
Yeah. Well, I want to.
You and your organization.
Management and coordination point of view, let's say. Well, as I have seen from the very beginning of the project, from the proposal, I think that in this project, it's clear the goals that each demo site wants to achieve. And this is important because the partners are not there to be just in an European project, to be there to know what is working. No, they know very well the things that they want to do. They know the things that they have to implement in their demo sites in order to achieve the reduction of greenhouse emissions, the energy efficiency improve. So I think that this is one of the points of the project. So when we, from the very beginning, you prepare the proposal knowing the benefits will be easy. Then for the implementation. Also, when you have in the project partners that are helping you to improve your management and control system, they are developing new sensors. I think that it's important also for the demo sites to see that, okay, we are here in the project to improve our processes and obtain a lot of data. And of course, we need this data, but we have to know the way to use it. So I think that also have horizontal solutions that are developing in the project help not only to the partners that are developing the DSS in that case, that to all the consortium. So I think that for me it's clear that if the partners are aware and they know very well the things that they want to obtain, it's more easier to implement the project.
think that's my best learning in this project.
Roberto.
Okay, well, from my side, I've been working in RETROFEED developing a digital twin, and well, in Turkey we have developed 3. And from this work, what I have learned is that, well, I have a shift in the view we can work with simulation, because usually in Turkey we offered consultancy services based on simulation to companies. And in this work, we keep the simulation models, mostly because the companies we work for don't have and don't want to have the expensive commercial software that we use. And now in Turkey, working in the digital twins, I have learned that it is possible to develop and offer models that have some real-time simulation capabilities. And the customer can have it without buying a commercial license. So this can be very interesting, because it can be interesting for our customer to have some power and retain this knowledge later. And of course, there are many difficulties that are related to the development of the model, as Jarek mentioned, but I mean, the possibility is there. In this project, we have given this digital twin to Optic, but in our working, we can do it to our customer. And also in the having been involved directly, but Kirsten has developed the new sensors based on imaging, and for us, this has also been a huge amount of learning in terms of image acquisition, handling, developing software to make sense of what the camera sees in zoom.
Great. Now,
I want to say something.
Oh, yes, Dushan.
Right. Basically, to what's been said here, for 2 things. First of all, to see actually, like different sectors, different corporates cooperating to each other. And this is something that has been a kind of in the spirit of EIP from the beginning. But then, secondly, this kind of reiterated, some of our ideas, because one of the reasons why energy efficiency is not really happening, there's basically no energy efficiency market. And it's very static, and things are going kind of push and pull, really, and it's not really sort of engaged. And from this project, and also from some other work, we kind of realize, that the key thing is not actually giving, the demo sites are very important, as kind of reference points. But the key thing is to enable this market is basically to focus on kind of auxiliary services, like what Optit is doing and Circe is doing, because these people are their enablers of kind of rejuvenating or enlivening this energy efficiency market. So I'm not really like super, worried about, following your question, about like, information sharing, with the other company in Slovakia, because the company in Slovakia, they might not, really, I mean, the people don't make, decision on the spot, on the basis of, kind of information. But there's this kind of classic book on the negotiation theory. It's called kind of Getting 2 Years. You probably know it from 70s. And to make somebody make decision is not that you need to make them positive decision. You need to prevent them to make negative decision. So this is why these kind of like, Optit and the others are important, because they can bring together, the solution, the financing with data, everything kind of come up together. So these companies, will just have to sign.
Thanks, Dushan. I just have one, we've got 5 minutes left. What I want to know, we're talking about, let's look at 2050 right now, where we want to be at net zero or decarbonize, whatever. Is the RETROFEED approach, can it solve it? Can we ramp up our the DSS? I mean, all of the elements that we've done, can we take it one level higher to full decarbonize it or net zero? Does it provide the foundation in the future?
No.
Well, I think one important learning also is that we see that the world is changing really fast.
Yeah.
And to have updated decision support systems with both data from the processes and from price, how it's developing. Everything is really key for the future, to make the right decisions for the future. You cannot base it only on your knowledge from last year. And also, I think, as we have seen when we've done the life cycle perspective analysis for environmental impact and so, is the importance of shifting perspective from different system boundaries to both look at what can we do in this process to make it efficient, but also to see throughout the value chain, where do we really have our impact? Are we sure that we are doing the right thing? To be able to shift perspective like that, I think with this changing world, that is really important.
Maybe I can add something to this. It will be boring because, again, I will tell
we have 3 minutes.
Yeah.
Last 3 minutes on this project.
One boring note. Okay. The data. I mean, the solutions has to be implemented. I think that the DSS has to work on the daily basis in some demos and collect data, analyze the data. Then the machine learning, AI, and everything can build upon and predict solutions which are not there yet. For example, 100% hydrogen firing somewhere. But if we implemented the solution and it works on a daily basis, we can later on upgrade it to, for example, to the net zero solutions.
Great. Well, last year I chaired a webinar where we had the rapporteur from the Environment Committee from the European Parliament, who said that he really wanted Europe, the EU, to have the reputation as the leader in green industry globally. And from everything I've seen today in this project, I think we're well on the way. So I think you should feel very good about what's happened. Yes, there's been a few bumps in the road, including having to wear a mask for a few years and things like that. But I think that an incredible amount has been accomplished, and you've all gained from it. And I've loved to see the demo sites in terms of the way. Well, so we moved here. I mean, how creative you were to try. You knew you had to solve it, okay? And your commercial entities, you had to do it. One of the barriers that didn't come out, and I'd love to explore, is on the financial community doesn't have a clue what you're doing. So if you're trying to go to a bank, I mean, I chair a working group for industry, the Energy Efficiency Financial Institutions Group, and those financial institutions wouldn't have a clue with what you're doing. This has to be explained better. Okay, so we have to do that. There's a lot of things that are going to be post RETROFEED that has to make this work. Anyway, thank you very much. And I think there's one other little section now. I think Jürgen and Diego have something in mind. Okay. Okay. Thank you very much.
Okay, so just a very quickly recap of the final event. So thanks a lot for all the speakers of the moderator that you have participated in the event. I think that we have shown very well the things that we have done in the RETROFEED project. And also, well, you have explained here your thoughts and your feelings about the future, about the challenges, about the main results of the project. So I'm just going to show you this table that these are the a recap of the impacts that we have obtained in the project. We are still calculating some of them because we have the last trials in the last weeks. But as you can see, in all the sectors where we have implemented the solution, we have increased the resources energy, or we have reduced the amount that we would use of, for example, the freak waste in the ceramic sector, the anthracite in the steel sector. So it seems that the solutions are working for that. Also for the energy efficiency, some of them are close to the objective, another one are a bit below, but in any case, they are working for that. And I think that mainly also we can highlight the reduction of greenhouse emissions that it is stated about to be about 30%. All the demo sites are reducing the greenhouse emissions, even the aluminium sector, just for this process, they are reducing even 75% of the greenhouse emissions. But in any case, for all the demo sites, the solution that we have implemented in the retrofit, the new sensor, the new management and control system, the DSS, has helped to reduce or to obtain this impact. So just to point out that well, the work has been done perfectly during these 4 years. So this is just for my words for that. So now I think that it's time for Jürgen.
Yeah. So I don't want to keep you very long. You might have seen that we have developed a little quiz, at the very end, not just for the product people, but also for everybody. Sorry. So I don't know if all of you are already playing, but so you can win, let's say, 4 or 5 points per round. It's a quiz where you have to answer 5 questions. They're coming very fast. You have 45 seconds. You just have to say yes or no, and then you either lose. But if you have 4 or 5 out of the 5 correct, then you get 4 or 5 points. And the current leader is Aleki with 615 points. But the point is, the quiz is still open until midnight tonight. Yeah. So, and I'm what we said is basically, I would like to invite everybody who has not yet done it to try it out. And I'm just here to guide you a little bit through it. Yeah. So we have developed it very quickly. So it's not a perfect game, but a nearly perfect game. You can use that QR code. If that doesn't work, you can just go to the RetroFeed website, which you find on the here the link of the program. It is just saying retrofeed.eu. There is basically the first button is a button to go to the quiz. And then what you have to do, because otherwise you cannot count your points, you have to register. So you have to put in an email, a username. You can use any name. My name is Quiz King. I'm still number 10. So you can use any name and a password. And then, like usual, it links you to your email account. So you have to confirm your email. Just as usual, check your spam folder. Once this is done, then you are basically coming back. And I don't know if we don't have it here, maybe.
No.
Okay, doesn't matter. So I can show you how it looks here. A bit small. So this you can probably see it from here. Right? This is a very easy thing. It's basically for mobile, but obviously it works on a laptop, but it's for mobile. And then when you confirm your email, you're coming back to this more or less this page where you have to put in again the email and the password. So don't choose a super complex password. It's not very sensitive here. You can use 1, 2, 3, 4, 5, 6, 7, 8 for today. That's okay. And then you can start playing. And now the good thing. There are 2 good things. The first one is the first 177 people win. So you can probably not beat the number 1 anymore, but you don't even have to. Yeah. If you finish 176, you will win. And we have this is a prize. This is a USB induction charger for your mobile, and at the same time, that is this kind of retrofitting thinking that it can do multiple things. At the same time, this heats up your mug, your coffee or tea mug. So you just put it in, And then you can put your mobile on or your earplugs or whatever it is, and your coffee mug. And you have always a warm cup of tea and coffee. This is the first thing. And now the second, the best thing, this is just for today, for people who are joining here. This is even more retrofitting. In retrofitting, we talk about multiple energy usage, or let's say based in multiple feedstock to use. So here we talk about multiple energy to use. So you can just plug this in a typical plug basically in the wall. You can plug this into your PC. And now the best. This is a solar charger. You don't even need connection to the grid. You just put it somewhere like this, and here you have two plugs. So you just plug this in here, the USB. You can take it, and it charges your phone and heats up your mug everywhere. So you have to be 177 at the very end. I don't know if there's someone online as well. You can still play, and if you live within the EU, we will send it to you by postal mail.
Okay.
So you can send it to a friend. They can still play until midnight.
Okay. I know the 37 right now, so I have to play a lot.
37 is
no. I have to
fairly safe, I would say, but
Christina has more than 400 points and me only 10, so I have to play more times.
Okay, so if anybody has any problems with doing so, I'm here to help you. If it doesn't work, that's the first one. The second one, if I trust you that you will play and that you all know the product at least after today very well, so that you will be amongst the 177. We have already brought the prices for you, which are here. So the final result will be seen tomorrow, but I bet that you will win. So that's why we bought it, and we save some postal steps. Voilà.
Okay, thanks.
That's it.
Okay, so that's all. Thanks for coming, and see you in the next event.
Where is it?
Also quickly to say that there will be lunch on the first floor in a couple of minutes, so you have time to play some games, and then for lunch at